Okay, welcome everybody to the Enable Backup and Data Recovery Bootcamp. This is part 3 or day 3 of our bootcamp series. Some of you may have been in earlier sessions this week, our level 100 and level 200 data protection segments. Those were roughly 6 hours of content, and we do have around 3 hours of content today focused purely on the recovery side with Enable Backup. And we're going to do our best here, technology allowing, to take you through some virtual disaster recovery, some bare metal recovery technologies, talk through some of the concepts around planning for disaster and ensuring that when that customer calls, you've got your environment in set up in a way that you can answer them rather quickly and keep them or get them back up and running in as short amount of time as possible. So once again, thank you everybody for your patience. I do need to make a couple statements from the lawyers just to keep everybody happy. We will talk about features, functions, technology that exists today as part of Enable Backup. However, based on inquiries, questions, and the direction that this goes in, there may be additional open queries and questions coming from the audience. I will talk a little bit about roadmap and features and functions of things that we are looking at to perform, implement, or update in the future. I will make sure to present those as forward-looking statements, so there will be comments toward that effect when I talk about anything that is currently on the roadmap or being discussed or considered for future enhancement, or things that are currently under development. Please don't utilize please don't make any licensing, purchasing, or buying decisions based on things that are not yet GA, or they've not completed their development cycle, as they could change either from a timing, feature, or function perspective before they are, or if they are released, okay? So with that, let's get this thing moving. A little bit of housekeeping here. You guys are on mute. Hopefully I won't be on mute during this session. But if you have any audio or video issues whatsoever, things are stuttering, they're breaking up, the video is not coming across clearly or not changing, things of that nature, please let me know in the chat session or question section so I can work on addressing those. From your side, if you're connecting over voice over IP, you might want to first disconnect and reconnect. Or let me know in the question section before you disconnect and reconnect, just so we can follow up and see if anybody else is having a similar issue, okay? The session is being recorded, and either this edition or one of the prior editions that I've already done will be available to you in the Enable MSP Institute, where you can watch on demand, okay? So before I introduce myself, I want to introduce the star of our discussion today, and that's going to be Bob the broker. I'd like you to meet him. He's going to be our customer today. Bob runs a investment firm where he and a few other folks work to help invest the hard-earned dollars of their clients. He utilizes a trading application as well as servers that are based on Microsoft SQL behind the scenes. And for today's scenarios, Bob's having a very, very bad data protection, or I guess data recovery day. So he's in the office, and he's been working with his systems, but he's noticed some issues with his trading platform. He thinks he's got a problem with the SQL database, maybe some bad transactions, some updates that were applied by one of his staff members, and it is giving him some problems. So I've got him on the line right now, and he is experiencing technical problems. He's looking to me. I'll be playing the role of the MSP today, trying to solve his data recovery needs. And we'll go through a couple different scenarios to try to meet a predefined SLA or series of SLAs that we have established for Bob and his clients. This is a slightly different approach to the training and storytelling type of approach that we've used this week for scenarios and technology and how and why and when. I'd be really curious to know how you, whether you like this. There will be a post-session survey, as well as the typical end of session scoring and ranking. Feel free to let me know if you like or dislike this type of approach, if the scenarios make sense, those kind of things. Wanting to apply to the audiences and make sure that it is relevant so that when disaster strikes or impacts your customers, you've got the similar concepts in place to take it forward, okay? So we've got Bob, he's on the line, he's had a problem, he's let me know that the server's not behaving properly. He would like me to try to get him back up and running. I've got a couple of different scenarios I can go through. I can, try to remote in and look at the system to figure out what's going on with it. Maybe I need to restore or roll back a database or an application. I've got file and folder restore, application, volume level restore, or I can perform some bare metal or virtual disaster recovery options to get him back up and running. Because we are still in the middle of his trading day, he's looking for me to get him back up and running with my 1 hour agreed upon SLA, and he's not having any internet connectivity, and his site is accessible and available. So I will do my best to get him up and running with that in mind. I don't actually have a technician I can send out on site right now. They're all out on other calls, or maybe I'm running partially understaffed right now due to sickness or illness. So since I don't have a technician I can send out, anything I do, I'm going to be able to do remotely through a remote connection. Just given the workload and amount of other calls that I have, I can't devote a lot of time to Bob at the moment right now either, without sacrificing the SLA that I have for other customers and their issues. So I have to keep that type of scenario in mind as well while I'm working to get him back into business. Okay. So let's set Bob down just for another moment here. My base SLA or my highest level SLA that I have is a 1 hour SLA. He's just put the call in, so I've got at least another 48 minutes to get him back into business before I've breached my contractual agreements with him. Okay. So we'll set him down and I'll do some more introductions and we'll talk about the scenario and how we're going to try to get him back up and running and what I'm going to try first. Okay. So my name is Eric Harless. I am the head backup nerd here at Enable. I've been with the organization actually now 8 years. This is an older version of the slide. I do apologize. I thought I'd remove this one and swap it out with the newer one, but I apparently have not. I've been in data protection for a little over the last 25 years, working with multiple different vendors out there in roles such as sales, support, system engineering, predominantly, however, product management. My last 6 years, or first 6 years with the Enable Backup product were focused on product management, building out backup and disaster recovery functionality inside of the product. The last 2 years, I switched from a product advocate in product management to a customer advocate in this head nerd role. So I'm focusing on community, education, training, building up a set of customer advocates, backup nerds, backup gurus, backup wizards, whatever you want to call them, that understand the product, that know how to utilize it when disaster strikes, and that can help to build out and grow and interact with that community so that our partners can hear from fellow users of the solution as opposed to people like me who do work for Enable. Okay. If you'd like to reach out to me directly on social media, you can reach me at eric.harless@enable.com. I apologize for my former SolarWinds address on the screen there, although that will still redirect properly to me. If you've got that in your address book, feel free to use that as well. If you want to follow me on Twitter, it's at @backup_nerd. There was a series of handouts that were in or available in the sessions earlier in the week. I may refer to things like our Enable Success Center, blog sites, things of that nature. And that particular handout is still valid for the session today. I may pull up a couple URLs and locations on the screen. If they are not already available in that handout, I can or will post them into the chat session so you guys have those links. Anyone that is attending today that did not attend an earlier session and get access to that handout, just let me know in the question section and I'll make sure to make a note to drop you a quick email with those handouts and those links available during one of our first breaks. Since we are recording and my voice is starting to crack now after a week of these, we will take some breaks at the top of each hour. Trying to align that for questions, comments, inquiries, and alongside the technology we're talking about. So we'll take breaks, while we're doing recoveries or while data is being transferred, things are going across the wire, things of that nature, okay? Because I don't want to do any type of smoke and mirrors if I can help it. I don't want to use any industrial lights and magic. I want to do environments where I've got real servers, real workstations, albeit lab servers and workstations, but still real servers and workstations, real virtualized environments, things of that nature, to show you what we're working through. In the event that we get some more technical difficulties or have issues with bandwidth or performance or store speeds, things of that nature, you can't always control that in a live demo. I do have my Julia Child set up as well, so that I can slide the casserole into the oven, pull out a already baked casserole and take you through some of the final steps, as well as I've got recorded videos that I can time index through if we need to look at a particular screen or function or something that I don't have fully accessible, but we need to talk about from a Q&A perspective. So please don't hold back on questions and comments. Feel free to call BS on anything that you see. If you don't like something or you want to question something, more than happy to go into depth on any of these additional topics, obviously as time allows, okay? Now, for agendas, I don't have that formal bulleted agenda like you'd normally see, but I want to talk about data from a recovery perspective. I want to talk about the fact that we're delivering on a single backup offering, and that backup offering is a file and folder-based backup solution, as I mentioned earlier in the week, but it allows you multiple recovery options. You can synthesize virtual machines so that you've got proactive recovery, meaning you've got standby virtual machines sitting, waiting inside of the hypervisor that can be booted on demand at a moment's notice once your customer calls and says, hey, I've got a problem. This requires you to proactively plan and await those type of failures for your customers. Those are going to be slightly more expensive types of service levels for them. So it's the highest service level you could offer, a proactive service level. You could call this your bronze, so your gold or your platinum level, your diamond level, or your good, better, and your best level. From a service recovery perspective, you name the plans. Obviously, I want to show some differentiation, but you can name your plans. In this kind of scenario, that failover is ready for you when the customer calls. And it's very likely that's the kind of a scenario we're going to utilize with Bob here, given that I've got now less than 42 minutes before I breach my SLA with him. And it's something we've already planned for in the event of a disaster or major data loss, that I can fail him over. And in this case, it could be for my convenience versus his convenience to fail over. Understand, though, that when you do fail over, or utilize a recovery scenario that causes you to switch over to different hardware, you do generate a secondary event. That secondary event is going to be me flipping him back to his repaired hardware or recovered system running inside of his data center or on his physical hardware, or replacement hardware if it's a major hardware loss. So anytime you flip over to virtual, you will have to schedule a time to flip back from the virtual back over to the physical or replacement hardware configuration. So while I'm saving some time up front, I really am going to utilize that time later, but I can take the customer's eye off the ball a little bit here. I don't have a situation where the partner is watching me, staring over my shoulder, are we up yet? Are we up yet? Watching data transfer across the wire, across slow internet. I don't have to worry about trying to fix a server that's down while they're waiting to get back into production. I can do that failover immediately, get him up and running, and then I can schedule repairing, troubleshooting, diagnosing, or calling a technician out, a Dell, an HP, or whoever it may be, to work on that physical hardware, or I can get my guys in when they're available to look at the software side, application and configuration side, okay? So while it is one of the best SLAs, it's also going to be the highest price to your customer and probably the highest cost to you, not as a service cost coming from Enable, but because of the infrastructure that you may need to have these sitting there and ready to go proactively behind the scenes, plus the time and attention you're going to have to devote to this to fail them back over to their physical hardware later. And that's really what we're going to see today, is the fail over and the fail back. And we'll discuss some of these other service levels and how they might be appropriate in certain conditions, depending on whether it's a ransomware attack or a corrupted database or corrupted file and folder type of configuration, okay? The mid-level service, reactive service. This is something that could be viable here as well. But in a reactive service model, it's one where you don't have a standby virtual machine sitting and waiting. In the event that the customer has a failure, at that point you determine exactly what you're going to do. Am I going to try to restore the machine in place while the customer waits? Am I going to attempt to swap a hard drive out of the system and try to rebuild the RAID array by restoring the data from a backup? Am I going to go in and try to clean up any of the files that were corrupted or damaged or possibly encrypted by ransomware? Cleaning the system is sometimes problematic in the first place because you don't know, did I get all of the compromised data off? Is there a back door or some additional access that's still available to the bad actor that was able to get into the system in the first place? So you guys may have some thoughts on this one. When you have a server that's impacted by ransomware, what do you do with that server? Do you just clean it, remove the files that have been encrypted, and then restore those files from a prior known good point in time? Do you nuke the server from space and bare metal or rebuild that server from scratch, or at least, going back to what you think is a known good point in time? What is your first approach there? And do you allow that approach to control the process, or do you rely on the customer's needs for that one? Who really controls the methodology in which you recover? Is it the customer's need, the SLA, or what's best for data recovery that you implement? Feel free to drop any of your comments on that thought into the question section. I'd love to hear about those. If they're appropriate or relevant, I may share some of those with the audience. Finally, it's those everyday disasters too. There's other types of things. It's not always hardware failure. It's not always corruption. It's not always a ransomware. It could be a file, a folder, an application, a database that's got some problems that you just need to roll forward or roll backward. So ideally, having one backup tool that you can use multiple ways to recover gives you a lot of flexibility. What they say, if all you have is a hammer, everything looks like a nail. And we really don't want you to fail over everything in order to get back just a few files or to get the data back from a small accidental corruption or accidental user error, things of that nature, if we can do it quicker, easier, and faster with one of the other recovery methods available to you. Ideally, though, you need to meet your SLA that you've agreed to with your customer. You need to be able to do that without overly taxing or impacting your staff, and without getting too stressed about it with the customer looking over your shoulder. So with that said, I've got now 37 minutes to work on getting this customer back up and running. So let's see what we can do to get him going here. So Jonathan, appreciate your comments here. Yeah, so you'd attempt to Sentinel-1 rollback if it's detected anything. So yeah, I like that. Sentinel-1, if it was able to catch it in its tracks and roll the data back, that's great. You kind of locked it out at the very beginning there. Now, it did find some way into the environment, so hopefully it's going to quarantine or lock that as well. But yeah, that is a good approach, definitely, or anybody else's EDR type solution. If you've got that in place right alongside your backup solution, that's great. It is multi-layered security for a reason, right? And hopefully backup becomes that last line of defense, and it's not that first thing you go to when there's a problem. That makes me think of something that I talked about a little bit earlier in the earlier session today. It's about data availability. Data protection and data recovery vendors have got you thinking that, oh, well, in the event of a failure, I fell over, I swap over, I spin up a copy in the cloud, and I'm good to go. Well, you pay a tax for that, obviously. You've paid costs up front for it, for the ability to do it. You pay the time and effort involved while you're running in that location, and then you've got to take the time and investment to roll back and ensure you don't have any data loss in either direction, if at all possible, right? So there are definitely other technologies that you can have in your toolkit to help your customers solve data availability, data recovery, data access problems without having to rely on the backup, which should be your last line of defense. But before you do that, why not also think about the configuration? If it's truly a mission critical, high availability type of operation, then maybe you should be utilizing additional steps inside of the hardware and the implementation. So making sure that the servers you're using are connected through UPSs. So that way you've got that battery backup available to them. They're going to have their lines conditioned from a network and a power perspective, and it adds a level of resiliency that can save you from a hardware failure. So buy the servers that will support multiple redundant power supplies as well, so that if you do lose a power supply in a system, you can have that to keep the system up and running. Look at machines that are cluster capable. So build your software solutions around clustered configurations. You've obviously got on-premise clusters, you've got distributed clusters that are across geographies. So if you can distribute your cluster configurations, utilize shared storage or cross-site replication, things of that nature, if your partner or your customer has the money to invest in that, those will help you maintain that availability, combined with all of those other security things, such as AV, endpoint detection and response, patch management, web filtering, spam and phishing controls coming through and monitoring your mail, along with various other firewall, whitelisting, and other software applications. Okay. So don't discount all of those pieces. Anybody that says that backup is your business continuity and your high availability offering, well, they probably got a software product to sell you, and it's not a bad last ditch effort for it. But yeah, you do ultimately pay a tax for that, and I'd much rather you solve your issue without having to rely on the backup software. Backup should ideally be that insurance policy that you never have to cash in, versus something that you're relying on, weekly, monthly, quarterly, those kind of things. Anyway, that aside, let's talk about the technologies that we're going to go through today. We're going to utilize our management console a bit. Now, when I say management console, this could be the RMM dashboard, the Essential server, or the backup.management console. All of these are going to have access to get your device name, your password, your encryption key. They all contain the downloads available for business continuity, disaster recovery, self-service restore, those kind of things. So when I talk about a console, I'm going to be utilizing the standalone version, but don't let that stop you. All of the recovery options we talk about today are going to be, let me think about that one for a second. Almost all of the recovery options you see today are going to be available to you inside of the integrated versions as well. I think RMM is going to have one limitation of a feature I'm going to talk about that does not exist in their platform today. And I'll point that out again when I get there, and I can talk to you more about migrations or other consideration if it's something you're looking for in the short term. Okay. The backup manager. We've already talked about the backup manager a lot this week, and while it is a backup client, it's also a restore client. It is capable of doing physical, virtual. It's the tool that's being used during bare metal recovery in a special mode on a version of Windows PE to get access to your data and lay it back down on top of disk that has no operating system on it. You're going to install that backup manager on each physical and or virtual server where you're doing recovery. You can install at the Hyper-V host level if you're wanting to store into a Hyper-V, or you'll store inside a physical server or a virtual machine on, say, your ESX box if you want to recover into an ESX environment to get the best possible performance. Okay. The local speed vault, we've talked about that this week as well. That's that local backup cache that you can utilize later when you're doing recovery, so you can restore at land speeds versus WAN speeds. I did have a little bit of network performance issues earlier today. I hopefully got that addressed, but we'll see today when we go to do our recovery. And if we do have any problems with that, we can still get through most of the process. I might just have to do that Julia Child effect and swap my casserole out. When I go to bake one, I'll pull out the one that's just finished cooking, so you guys can get all aspects of recovery today. And my goal isn't so much for you to see a successful backup and restore and failover and virtualization today. It's to get you familiarized with the tools so that you understand how to build out and test some of this so that you can do it yourself in your own lab environments. And you've got that familiarity before you get that first customer call saying, hey, I know we've been using this for 6 months, but I need to recover today. And you don't want that to be the first time you actually have to do a real live recovery for a customer. I'd much rather you have had some practice with test and lab or own your own internal machines doing virtual and bare metal recovery. But realistically, for every, and I don't have a good statistic on this one, but for every 100 machines you're backing up, or every 1,000 successful backups, maybe you're going to have one type of restore operation, or every 10,000 backups, you're going to have one type of restore operation. It's going to vary by partner and by customer and by industry, but they should be a very, very small percentage of number of restores you do to overall daily backup sessions. The Recovery Console. This is an application that we are going to introduce today. This is a optional multi-session recovery tool. There's no charge, no cost for this tool. It's a tool available as part of the service. You install this wherever you want to do file, application, virtual machine type of recoveries. And because it is multi-session, I could use it to restore multiple servers or workstations back to a hypervisor, centralized restores of multiple SQL databases all back to one server in different directories, so that way I could take advantage of restored SQL databases to populate a reporting service possibly. Effectively reutilize my backup and testing environments for data analytics. So it goes beyond disaster recovery and business continuity and availability. You can use it for other business purposes in some cases. We're going to talk about bare metal recovery and utilize that from the failover. The failback tool. So we'll use Recovery Console and our virtual disaster recovery technology to build and fail over to VMs. We'll use bare metal recovery to take and fail back from those virtualized environments back to the physical hardware, or in some cases to virtual hardware, or even to create recovery into virtual platforms we don't officially support. Maybe like a Nutanix environment, things of that nature. Any hypervisor where you can mount an ISO image or connect to a USB drive in order to boot configurations. And then finally, time allowing, we'll talk about Virtual Drive. It's a self-service restore application that presents the restores to you inside of Windows Explorer. If time does not allow for that one, it is some interesting technology. I would encourage you to take a look at it in the documentation or install it on a couple of your servers. You can explore it. Just the high level for this thing, it allows you to look at your dedupe catalog as a virtual file system, pick a data source and a timestamp, and look at the data in a file tree structure and drag and drop it out to the system in order to trigger the restore behind the scenes. So something your end users could do if you wanted to allow self-service restore by them. Okay. So we are now at 28 minutes to get Bob up and running, and I'm still talking through concepts and scenarios and why would we do this or how would we do that, but rest assured we'll get him back up and running before the 1 hour SLA is up. Here's a quick look at the different kind of scenarios we can restore to. Taking backups from either on-site or remote distributed environments, being able to back up through the firewall out over port 443, sending data that's already encrypted by the client, utilizing AES 256-bit encryption. I can send that to my local speed vault, which is recommended but not required. I can send that off to an enable manage private cloud storage location where it's going to be compressed, deduped, and encrypted at rest. And then that copy of data or that speed vault copy can be utilized to restore the data back to that on-premise location, a secondary data center, a colo, a data center you manage, or even to the Azure or like an AWS cloud infrastructure that you have access to or that you control. I will try to talk to you guys today about some of the enhancements and features that we're looking at on the Recovery Console or as a Recovery Console replacement, as well as expanding out the continuity services which deliver our hosted disaster recovery testing today, and how we'll utilize that foundation or platform to expand what we can do for you from a recovery perspective going forward. Hashtag forward-looking statements here, the things that are currently being fleshed out or worked on or contemplated for the future. Okay. So back to Bob. Bob's one of my most demanding customers, and for your most demanding customers, you're going to need some type of proactive recovery solution for them, or at least for some subset of their devices. There's probably not too many of your clients that require all of their systems to be available within an hour of a data loss, a failure, or an event that didn't compromise their building or their site. But in Bob's case, he's got a handful of machines that are business critical that he wanted to get back up and running within an hour. Now he did also agree that if his site wasn't available, the internet wasn't available, things like that, it was a major site incident, then he was okay with up to a 4-hour SLA to fail over to a secondary colo environment that we've set up, or to my location or another facility. So 2 SLAs that we've really worked with here. Now, Bob, like I said, they could be one of your most demanding customers. They could be one of your most profitable customers. It could be one of your most difficult customers, or all three of the above, right? So for Bob, what we're going to do is we're going to utilize virtual disaster recovery technology to create standby servers. We're going to keep those servers up to date, utilizing our continuous restore capabilities inside of the recovery console and a function of the virtual recovery. My recovery console, I'm going to have multiple instances of that installed at different locations, configured at different levels or intervals, so that I can meet those different SLAs as necessary and control cost to a point that are still within the range that's acceptable to Bob, and that I can make enough of a profit on to cover my time, my monitoring efforts, and the extra overhead that I'm going to have later when I go to fail this over. Not to mention though, let me mention also that this does give me peace of mind also. It means that I know going into these that I've tested this and that it works and that I can get the customer back up and running. So while these are more timely, more costly, more expensive to manage, they're also a lot less stressful from the standpoint of being able to get them back up and running, because you've really done all the hard work up front. You just need to go through and flip the switches and perform the actions to get the customer switched over when it's time to fail over. So there is no that guesswork with the customer looking over your shoulder while you're waiting for data to trickle down over a connection that seems to be running at half the speed it was rated at or that you're contracted it for. So let's get into my environment. To get Bob up and running, the first thing I have to do here is I have to VPN into his environment and bring up his terminal server or his hypervisor so that I can switch on those standby virtual machines that we've got configured to update each and every night or shortly after each and every backup operation, okay? We'll take my first step here by connecting into one of his two hypervisors that we have on premise. We're going to connect into Ivy. So first off, we're into Ivy here, and Ivy is a Hyper-V server. I've got Hyper-V Manager in here that can manage both Ivy and Savage from this system. And you can see here, this is where Bob's production virtual machines are residing. So Ivy controls or runs 15 different servers here. And these are varying levels of feature and function. Those guys are all up online and running right now. Server number 2 here, the one I've got currently highlighted, is the one that's giving Bob a problem. Now it's not off, it's not down, but it's not performing correctly. So like I said, I could do a couple of things. I could roll a technician, I could try to remote into this system, I could do file and folder or a database rollback, maybe try to undo some of the patches that were applied to the system by restoring or rolling back data to a previous known good point on the live environment. But any troubleshooting I do to this is going to take some time, and as I've procrastinated a little bit talking to you guys, I've now got 22 minutes to get this system back up and running before I breach my SLA. So I want to do something that's not going to be very disruptive to me. I'm not going to have to roll a technician, and I can do from the comfort of my remote control software or my RDP connection into his hypervisor. So the first thing I'm going to do is I'm going to come in here and I'm going to go ahead and shut this system down, because we know it's got a problem. He's told me as much. I'm not going to diagnose it right now. I'm going to come back and diagnose this later once I've isolated it from the network and I've got him back up and running and not looking over my shoulder to see when is he going to be available. So I'm going to come in and just turn off that particular machine. So it has physically been powered down now. And the reason I did that is because I'm going to bring up a standby system, which has the same IP address, same NetBIOS name, and I don't want those two to conflict on the network at the same time. I guess technically I could have brought it up in a different subnet or on a VLAN or in a NAT or behind a internal only network first to play with it and see if it's the right system, if it's going to work properly. So whatever order you do that in, you just want to make sure that you don't have both of them on the same production network at the same time, because they could cause conflicts, especially if it happens to be a component of a larger set of servers or resources. So a group of servers that run a function, a domain controller, an exchange server, part of a cluster, things like that. So you do want to control that and bring them up in a controlled configuration, a controlled environment. So in addition to that set of production devices that are here, you'll notice up here I've got a set of standby virtual machines too. And these standby virtual machines looks like the first one here, this top one is actually running right now. But I've got server 2, 3, 4 through server 8 all sitting here in standby status. These are getting updated offline after each and every successful backup of the production system. And then they'll get booted, screenshotted, and then powered back down, and the checkpoint will be erased so that we undo any changes made by the boot. So this one right now is automatically generating that screenshot behind the scenes right now. It'll probably shut down in just a few moments after that screenshot is generated. So I could fail over to one of these, but they're running on the same hypervisor as the production systems. They're here, as one local fault tolerant component, but I've got another hypervisor I can utilize for this, and I want to isolate this to a separate hypervisor in case I need to actually start this one up over here or isolate it and make changes, move things around. I want to live migrate my servers between systems, things of that nature. So I've got a whole series though that are here, and I'll show you how these are configured here in just a few minutes after we get Bob back online. We're going to go look at Savage now. So if we look at Savage, I've got a handful of the more mission critical systems sitting here on Savage as well. And these are virtual machines also. They're all offline. Actually, as you can see here, I've got two versions of server 2 here. And I need to think about why I'm seeing two versions of that right now. Right now, possibly some of the testing and working that I was doing a little earlier in a previous session. I probably cloned or built the second one through virtual recovery and just didn't get it fully cleaned up. But I've got multiple standby copies of a server 02 here that I can bring up in the event of a failure. They're going to be from various different points in time, depending on the configuration of the SLA. Okay. So to get Bob up and running, all I really need to do is pick that server that I'm going to utilize in place of the production one and start it. But before I do that, let me go over here and grab my recovery console. It's sitting right here on my desktop. And here you can see my recovery console. So I've got a series of machines that are either set up to do continuous restore and get updated based on nightly backup operations or sub-daily backup operations. I've got server 1 was updated or last restored a day ago. Server 2, which I've turned off continuous restore for now, was updated 8 hours ago. A day ago, 10 days on these systems. These are ones that are currently retired or powered down. 14 hours ago on this one, it's blocked. A day ago, it's blocked. These blocked systems are systems that I've booted to test, and then I've manually went in and utilized those systems. So now it's realizing that I've made changes, and it's blocking the continuous updates. So until I come in and right-click and then block these to say, allow new updates to be applied to these systems, they're going to be preserved in their current state. Okay. I see this one was last restored 8 hours ago, so that's within my 24-hour SLA that I've defined for recovery point objectives with Bob. So this is the one that I'm going to actually want to start up and get running. We'll set my recovery console aside. We'll find that system, and let's see if we can get him to start. Now, I did not change any of the configuration. This is going to come up with the 2 gigs of memory and the 2 virtual CPU cores that it was created with by the recovery console. That means that it may come up in a depreciated fashion. It's going to run a little bit slower. The resources are going to be a little bit more constrained. But this allows you to over provision. You can have more systems running and restored on your hypervisor than you would power up at one time, assuming you're never going to fail over more than a third or a quarter of those protected systems at any one point. It allows you to over provisioning, saves you money, time, infrastructure, and ideally virtualization's been that great equalizer and that great enabler when it comes to business continuity and disaster recovery, because you can play that gamble that you're not going to fail over every machine all at one point. So we're going to come in here and try to connect to this guy. And we'll see if we can get him up. So I've got my machine here. Now, ideally, if I was going to get Bob running into full production mode here, I probably would have come in and added a couple additional CPU cores and some additional RAM to the system. It's not a super powerful server though from a lab perspective here, so I think we're going to be fine. If it's too slow though, we will work on adding some more resources to it. Oops. So the thing to understand here from a recovery perspective is that this system was blast backed up in the middle of it running. We utilized VSS to ensure that we had open file protection and things of that nature, but this is coming back to you from a state where it was last opened. So what you might see occur in certain save states. You might get the occasional error or pop-up here that says, oh, hey, the system was not shut down properly because it didn't recognize a shutdown command at all. The last it knows, it was in a running state. You can open up your backup manager here. So we'll go ahead and open up my browser, and we're going to navigate to localhost port 5000. So I can bring up my backup client. And what you should know here is that the backup manager is going to come up either in restore only mode, or it might come up showing a slightly different session state. I'm actually seeing a last error here. Let me see what that last error is. Previous initialization attempt failed due to the error could not resolve host name. Okay, so the last time I brought this up, it had some connectivity issues. And I'm not seeing an identified network right now. So maybe this virtual machine doesn't actually have network connectivity. So that would be one of my additional steps to get this guy online, would be to go update DNS to point it over to the system, make sure that I've got a virtual NIC or that I have moved it over from an isolated network into a production network. Once again, this is all stuff inside of my hypervisor, or it's a VPN and connectivity that I need to create between my end customer and my colo or my offsite location where this VM might be hosted or coming up. The function is really no different if you're running on-premise at the customer's location, you're running at your colo, your data center, your facility, or inside of a public cloud like an Amazon nested inside of a Hyper-V environment. I'm sorry, an Azure nested inside of a Hyper-V environment, or an AWS where you are maybe running in an EC2 bare metal instance or something of that nature. Okay. Let me see if I can address that network connection issue. View connection settings. I won't spend a lot of time on that one because configuring Hyper-V, not necessarily the focus of this one. I want you to see the tools and show you how we got the standby system here. I also want to talk to the comment I made earlier about smoke and mirrors. Right now, you really haven't seen me restore anything. I haven't opened up a backup console. I haven't really configured a restore. I haven't transferred any data. Everything we've done so far has been about proactive recovery. It's about the things I did before today to make sure that the VM was sitting there and waiting and ready to go. It's not about what I'm doing right now. I've taken some of the pressure off by being able to have it ready and available in the standby mode. Let's see, Hyper-V, virtual SAN, virtual switch, new switch, private virtual switch, new virtual switch. Okay, private network, external network, and apply. Interesting. Okay. You're applying virtual switch properties. I do want to see if I can get this guy to actually fully recognize on the network. That is going to be the final step, either that or opening up a VPN connection for the client. But okay, so we've got a NAT environment now. There we go. Okay, now I have network connectivity. I've got my backup client in here, and this guy can be utilized now so I can continue to do backups for the next 4 hours, 4 days, 4 weeks, however long I manage to run inside of this virtualized environment while I'm working on replacement servers, repaired servers, or maybe even deciding to physically or permanently migrate this customer's environments from a physical host into hypervisor environments. Okay. Now, this is in restore mode, so to make it start doing backups, I just need to hit the button here to switch into standard mode so they can start doing those regular scheduled backups based on the predefined schedule. It's already configured, it already has my selections, it knows exactly the machine that it's working on. If you go to preferences, you can see that my system is configured over here. I may need to go in and add my local speed vault so I can keep it a local copy, but for the most part, it's going to be configured and ready to go as soon as I switch into standard mode. Let's see now. So let's talk about how we got to this point, okay? So without a plan to fail, I'm sorry, without a plan, I'm sorry, I don't want to say this. If you fail to plan, here we go. If you fail to plan, ultimately you are planning to fail. So coming into this, not knowing whether that system was going to be recoverable, not knowing that it had booted successfully last night and generated a screenshot in the console and sent an email to show proof of life and the ability to log into the system, then when Bob called, I have to go check my logs, check my environment, make some guesstimates or educated inferments based on what I've seen in the past and as to whether I think this is going to be recoverable and choose the right path. So given that, let's talk about the proper planning, preparation, testing, and recovery as you build out a plan. So if we went with a customer like Bob, I need to know their business needs, which of their servers are business or mission critical, and then set expectations with your clients based on their needs plus the realities of their budget. While everybody would love 100% availability and clusters and all of these things, there's really only going to be a handful of systems inside of their organization that need that super frequent or super quick service level, that 1 hour local recovery. So for Bob, we determined that there's a small number of servers that need that 1 hour local service level. And in the event that he had his entire site compromised, or he didn't have access to the internet, or he couldn't get into his facility, then he was looking at a 4-hour failover to a remote data center where we would be VPNing in, and his users would be connecting to the data center from their home offices using their home internet and their laptops. Obviously, to do a site-to-site failover and to be able to connect without access to your normal facility, you've got to have roaming profiles and VPN configurations and things of that nature. You've got to plan for this. So it's not about, oh, hey, we had a failure today, let's spin everything up in the cloud. You have to be somewhat prepared for that up front. Have it so that your employees can work remotely. One of the things we've all learned through the pandemic here is how to convert an on-premise workforce into a distributed mobile workforce. So this should be a lot easier now going forward to deliver business continuity and availability with a cloud-based service. In Bob's environment, we obviously have to go and turn around and set up that infrastructure appropriately so that we've got recovery consoles and hypervisors either staged locally in his facility or in my colo or at a secondary data center he controls, or his home office, which is going to act as the secondary site, maybe in a public cloud, Amazon and Azure, what have you. Okay, and ultimately you do want to under-promise and over-deliver when there is a failure. So analyze the environment, figure out what's going to work best for you, what's going to work best for the customer. If you are going to breach an SLA, if you realize that, hey, I can get this server back in 1 hour and 15 minutes, but it's going to save me, 4 hours of work later, and I know that I can do that, well, then you have a talk with your customer and say, you know what, hey, is it acceptable if we actually ignore the 1 hour SLA today? It's going to take maybe 1 hour and 15, 1 hour and a half based on estimates, but I believe it'll save us time in the long run. If you can get your customer to buy in, that's great. Use the right tool to recover the data and get the data back as quickly as possible, but don't cause yourself additional work later. Don't fail over if you don't have to, because then you can eliminate that fail back event. So to build that implementation or that preparation for Bob here, what do? We took a production server where we already had his SQL application, his trading software, and we set up the backup manager with backups of system state, system volumes, SQL server, and we run a regularly scheduled backup. I think we actually run a backup every 4 hours or every 6 hours on this particular client because we wanted a shorter or a smaller recovery point objective as well. We set up the recovery console on a recovery server that's a Hyper-V system or a VMware system that's at Bob's primary location. And this could be reclaimed hardware from a hardware refresh that you went in and added additional drives or CPU cores or additional RAM to, something to bump its ability up a bit. It could be out of warranty hardware. It could be fully brand new in warranty hardware. But if you've got hardware coming off lease and you can standardize across customers and things of that nature, off lease hardware is a great way to start that, because these are standby systems, failover systems, and they're going to be running in some kind of over-provisioned or deprecated stance anyway. You don't necessarily need or may not need to have the most powerful or fastest running systems there. A couple small tweaks to some of that reclaimed hardware is a great way to start. You could even go as far as, in a pinch, utilizing a quad-core better laptop with a terabyte or 2 terabyte SSD and 16 gigs of RAM to emulate or act as a proxy or stand-in for that failed server until you can get parts or hardware ordered through the supply chain. Okay. So we've got that local recovery console server. We've got it configured to do continuous nightly restores. Then we've got a secondary recovery console set up at a cloud continuity location. Like I said, it could be a colo, a secondary location, a home office, your colo, or your facility, a public cloud, wherever it wants to be. In that environment, this could also be, new hardware or inexpensive reclaimed hardware, but it's going to be configured with maybe lower performance spinning disk, less number of CPU cores. This is only going to be used in the event of a true emergency where we have to get things here as a backup plan or a backup plan. And here you might have the recovery console configured, but you may not have any actual daily restores happening. You only occasionally come here and spin up a restore just to test something or check it. And it could be a day or a week or a month, or have never done a restore of that particular server until the customer calls. But we've got options now in these configurations. That's why I say these could be more costly, because there is some hardware investment or some facility or some bandwidth or disk investment, and there's time investment obviously as well. So let's kick back into the recovery console environment. You know what? I apologize. Let's kick into our first break, which we are at the top of the hour now. So we'll kick into our first break as soon as I can find my break slide. And then we will go into some of the depth of the recovery console as soon as we get back from our break here. So quick recap here. What have we done? We've taken a call from a customer's got a problem. We made a determination we're going to utilize our default high level SLA. We failed over to an offline virtual machine that was up to the point in time from an 8-hour ago backup. And we switched that virtual system on, updated our network connection so we could get him in the environment, and we went about our business. This means now that I can roll a technician later to look at the production environment, figure out what was wrong, start to create a formula or a plan to get him back into production later. I can turn backups on so that if he's here for a couple hours or a couple days or a couple weeks even, I continue to back up the data. So I don't really have a lot of risk right now, and I can do the data recovery or the failback on my own schedule, after hours, in the evening, or even over the weekend. Once I know I've got the problem resolved. If I come into a situation where I'm halfway got it back up and running and I have another failure or another issue, I haven't disrupted the customer at all. He can go about his business. So that is the ideal scenario when it comes to business continuity, right? The customer's not breathing down your neck, and there wasn't a lot of hard lifting just yet. Now, it doesn't mean we didn't do some stuff beforehand. So let me show you how we got to that point. All the planning and preparation that went into making that recovery console do what you needed. So we're going to flip back into that environment. So we can see here that because I booted up that environment now, the O2 server is currently blocked. So we can't continue to do any more restores on that system. So I'm going to turn off continuous restore so it doesn't even try anymore. So that's great. But let's talk through the configuration here in this recovery console, what you're actually seeing. So this particular system here, we've got multiple virtual machines that are configured for either continuous restore or on-demand restore, and they've been last restored within a day or a couple days, I guess a little over a week here on these systems, or within a few hours. If I click on any one of these given machines, you can look on the right-hand side here. I'll make this a little bit bigger, and you can see a series of the restores that are happening here on 1014, 1014, 1014, at 2, 252, 352, 610. So it looks like I've got some of these that are restoring, on the half hour type marks. I've got a virtual disaster recovery down here that failed for some reason. I've got a blocked environment where I was doing another demo. So you can see here that it's not a pristine environment. I've been working with it. It's a live production environment. Here, just trying to mount a virtual disk. You couldn't find a driver. It needs a driver update, so I've got a pending update for my virtualized ESX environment. But since it is a multi-session tool, this machine, these restores are all working great. Completed. And this system is able to, coordinate updates, to pause restores so that it can do a shutdown and restart and update itself behind the scenes, things of that nature. It does have some pieces of it that run as a service for resiliency and availability, and there are a couple pieces of this console that are still user mode applications tied to an active user login. We'll talk about that a little bit more when I talk about futures and places that we're going with recovery console replacements and enhancements to get around some of those user mode limitations as well. Some scripting and some automation I have available for you guys as well. The console does look very Windows NT 4. Effectively, this is just a wrapper around the backup manager that controls multiple instances of the backup manager on unique ports and orchestrates the different check-in of the cloud status and orchestrates the restore for the various machines, okay? How did I configure this? How did I get it going for continuous restore? Well, I started out by adding a new device, and it was the device name, the password, and the encryption key or the security code for that device. If it's one that's managed by us, you can go pull it out of the backup.management console, out of RMM, or out of Incentral. If it's one where you control the key, private key encryption tied to standalone backup only, then you would enter the device name and password from the backup.management UI, and you would enter the security code or the encryption key from wherever you're storing and managing those keys. Something I said in the earlier sessions is that you should be testing those keys that you're managing and keeping yourself to ensure that what you've written down is a valid key for recovery. So sometime within that first 28 days after deployment, why not spin up a recovery console, pump your credentials into it, make sure that you can start a file and folder or a database or a virtual disaster recovery. You don't actually have to run it, just make sure you can configure the device and then it actually validates your key. If it doesn't, then you need to either reconfigure the device, redeploy the device, or maybe convert it over to passphrase with some scripting and automation policies that we have to do that. Now, once you enter the device name, password, and the encryption key, you can configure the device. So you can right-click on a device here and say configure, and you can choose the type of recovery that you want to perform, either an on-demand or continuous restored session. So file and folder data to original paths or to relocated paths. And because this is file and folder data from another system that's going back to this Hyper-V host right now where I have the recovery console installed, most of the time you're going to do a redirected restore to an alternate path so that you don't overwrite your recovery server's operating system with the operating system of the machine you backed up. Make sense? Exchange restores. You can restore directly back to an active Exchange server, or you can do a redirected restore into a container where we just drop the EDB and the log files for that particular Exchange server. If you want to then turn around and attach it to an Exchange recovery storage group, or you want to mount it with a GRT, a granular restore technology tool, to be able to pull or siphon data out of that EDB without attaching it to Exchange. Network share data we can restore. VMware, this is a hypervisor to hypervisor restore, so I can restore VMware data backed up at the host through their vStorage API directly back to the original or to an alternate ESX server. Same thing for Hyper-V down here with the Hyper-V data source, Hyper-V host level backup to another Hyper-V host, restoring those underlying VMDKs and VM configuration files. VMDKs, VHDs, and VM config files, yeah. SQL database restores back to original paths if you've got SQL services running on the machine, otherwise to alternate paths where we just lay down the databases and the log files. And then of course you can choose to connect or attach those or mount those to a running SQL instance here on the recovery console machine so that you can use them for reporting services or availability, or to crack them open to pull transactions and tables out that you're going to work with, if you're a DBA and privy to that type of work. Virtual disaster recovery is what we use to synthesize a virtual machine from a file system and a system state backup. So that's what we'll have configured here. It's possible to have multiple data sources configured if you like, but don't over configure. Don't configure virtual recovery and file and folder restore. You're just going to complicate things and be causing more problems than solving problems. So when I go into my configuration for Hyper-V here, the very first thought is, what data source am I restoring to? I'm sorry, what hypervisor or what target am I restoring to? So is it a Hyper-V host? Is it a VMware ESX host? Or is it to a local VHD, VHDX, or local VMDK file that you would then connect to VMware Player, VMware Workstation, Oracle VirtualBox, the Hyper-V role inside of Windows 10, or mount through disk management inside of a Windows server or workstation? So different virtual disk containers or virtual targets. A couple different options here. I typically recommend these first four options are always checked. That's going to be the ability to put the backup or the restored machine into a restore only mode so that it doesn't start doing backups even when you boot it until you're ready for it to skip files that have not changed. That's kind of related to our change block tracking and True Delta technology. If we know the file hasn't changed based on metadata, don't even worry about it. Just skip right over top of it. Don't go through and look at it from a hashing perspective. The ability to remove obsolete data from the target computer. This is the difference between a replication solution, a synchronization solution, or a continuous restore solution. If all we did was restore data and restore data and restore data and restore data, eventually we'd be restoring files that were changed but ultimately got deleted off of the source. By allowing us to monitor those deletions on the source and apply those here at the destination, it creates it more like a replica with a checkpoint than it is like just a restore that's happening over and over and over again, only laying down files. If you think about that, restore only lays down changes. In this type of scenario, though, for availability, I need to lay down both changes to new files and existing files, but I also want to remove files that are pulled from the system so that I don't have cookies and configs and other things that don't belong, applications that have been uninstalled, things of that nature sitting here on the machine causing problems or conflicts. This fifth option here to change the FRS and DFS service to authoritative. You're going to utilize this in situations where you're restoring multiple domain controllers, maybe doing site failover, things of that nature. Typically, you're going to avoid utilizing this setting unless you've been instructed to do so by support, or you're in the middle of restoring and recovering your domain controllers or one or more of your domain controllers into a virtualized environment. But in those kind of scenarios, I would suggest you reach out to support and consult with them on the exact or proper order and process involved there. This final checkbox, I'm going to uncheck it and recheck it so I get the warning. This is the option to boot the virtual machine after a daily or hourly or nightly recovery test. So it'll boot the machine, screenshot it, power the system back down, and email you or post that screenshot into the console so you can view it as proof of life or proof of performance. This is warning you, though, if you're going to do that, to isolate this particular restored machine on a different network, subnet behind a NAT, or an isolated environment so that it doesn't cause a network conflict with the production system, domain controller, hypervisor, VMware machine, or Active Directory system, those kind of things. I think everybody can agree here, you don't want two machines on the same network with the same name, the same IP address, trying to talk to the same set of other servers, right? So what do we have next? Well, I've got a restore tree. I can do virtual recovery, basically restore everything that I've protected, or I can expand this so I can see my disk structure and my volume or directory structure underneath that, and cherry pick what I want to restore and not restore for a given environment. So I can choose not to restore certain users. I can choose not to restore certain directories, dump locations, software installation folders, so entire volumes or partial volumes, and don't think about this as to what I want to restore right now for a single session. Think about this as what I'm going to use for continuous restore. So think about the containers that you're really going to be continuously restoring on a day-to-day basis. And understand, I told you guys or taught you guys in the level 200 section session about the file inclusion and file exclusion. So depending on how you make your selections, it controls as to whether new data underneath that container is automatically backed up, or in this case, automatically restored as part of the restore process. So depending on how you come in here and you select everything and then deselect the D volume, that means that if a E and F, a G and H and I volume all showed up, well, they would be available for restore because I started by selecting all of the systems and I deselected what I did not want. If I were to come in here and deselect everything and choose only the C volume, now any new volumes that show up on the protected system, even though they were backed up, would not automatically be part of my continuous restore. And this way you can ensure you don't over provision or over create or consume too much space inside of your hypervisor or your virtualized environment, especially if that D, E, F, H, G, H, and I are all iSCSI volumes or they're external data volumes that you're just going to unmount from the source and then reattach to the destination because they weren't corrupted or damaged. Okay, so how you select these does make a difference. How am I going to name the machine where I'm recovering it? Where am I going to restore it to? Is going to go back to a standby location here. I use unique folder names. That way I have everything self-contained, the VM config files, as well as the actual virtual disks that are tied to them. Makes it a lot easier. What virtual switch am I going to apply in a Hyper-V environment? If I were doing this on ESX, I would enter the server username and password for the ESX server, the vSphere environment, and it would present me the machine name, data centers, host, storage, and resource pools available inside of that VMware server or that cluster configuration of VMware servers. In addition to picking the server information, you're going to pick network information. So if it's on the same network, you can have it grab IPs through DHCP. If it's static, then it would keep those IP addresses that were originally configured for the machine, because we're effectively restoring it, or almost creating a replica or a clone. But you could also assign additional IPs or alternate IPs, subnet mask gateways, and DNS servers down here. And the little question mark next to these will explain all of the different optional components down here that you can configure. Finally, we have the ability to configure a local speed vault. If it's in the same network as the production environment, or you've used a seed tool to build a speed vault behind the scenes, then we can use that, and we can pull 99% plus of this process across from the speed vault, and we only need the internet now to do the encryption key validation and to pull down that first copy of the backup register, so we have a catalog we can choose from for restore points. Okay. So I'm gonna go through a couple other little caveats here that exist for this recovery console. I'm going to talk about or lead up to some of the features that are here. I already mentioned that this guy runs as does have some components or pieces that run as a service, but since he is partially user mode, I've built a couple different scripts and scheduled tasks to help further control that. There are third-party tools you can use that can allow you to run this recovery console behind the scenes, to restart it after a logout, after a Windows update, things of that nature. But without those, you do have to remain logged into this particular server for these restores to process behind the scenes if they have the continuous restore box checked. If you log out or it does do an update and you fail to log back in, well, then none of those daily restores are going to continue to run. So you won't be getting those emails. You won't see those coming through saying, hey, we've had successful boots. You'll see that it hasn't checked in inside of your management console, things of that nature. I've got two particular scripts here right now. One that can cycle your recovery console services, basically shut down and restart the recovery console for you so that we can flip you from a session 0 running session inside of the OS running by a local administrator happening behind the scenes and your current logged in user. I've got a script here to look at your current recovery console sessions. It'll look to see which of these are currently actively running a restore, and it will launch those individual recovery console or backup manager UIs. The equivalent of coming in here and right-clicking on one of these and saying launch backup manager. And it'll do that for you dynamically, and it will dump out a lot of different statistic information based on that restore utilizing PowerShell, so that you're not in here scrubbing logs and looking at various settings or having to look inside of the GUI to find them. These are all prototype scripts that I've been working on, and I've been doing those in parallel while development is building out their next generation recovery console replacement, which will use a lot of our technology that's currently in place for our hosted disaster recovery testing service. So I'll go to that in a few minutes here and talk through that a little bit, explain how we will expand that currently and in the future to continue to expand our continuity offerings. For this particular system right here, right now, I think I've got a scheduled task set up. Let's see, I'm going to go to task scheduler. And inside of task scheduler here, I have, let's make this a little bit bigger, library. I have a scheduled task here to start the recovery console. It's triggered on one of 4 different actions. At system startup, it runs the recovery console. When a user disconnects from any local or remote user session, so you're logged in remotely or you're logged in locally, if you log out, then it will restart the recovery console because it's going to shut down when you log out. It'll restart it. And then, of course, if for some reason the recovery console is stopped while a user is logged off, for whatever reason, then each day at 10 p.m. it's going to restart that recovery console just to ensure that you're available for restores if you need it. Now, it doesn't run multiple instances of this, so if one's already running, it won't start a new one, but it ensures that you've got your bases covered to restart the application. What is it doing? Well, all it's really doing here is running the recovery console in a service managed condition. And I did go in and change the log on as rules for the recovery console service to log on as an administrator role versus a local system role. That way it's got access to network shares, network connectivity, local speed vaults, and various volume paths, whereas the local system account would not. Okay. Like I said, I haven't published these externally for partners just yet, but if you are interested in getting access to some of these scripts, some of these prototypes, you can schedule some time with me. Drop me a quick email, hit me on social media. We'll schedule some time where we can go through and build up your recovery environments to utilize these tools or scripts. There is a third-party tool I can recommend also called Always Up, which does some very similar items here. Controls the session 0 mode, restarts, monitors, sends emails, and can run other various scripting and automation to keep applications like the recovery console or any third-party application really up and running. You can use task schedule like I did here. You could use some tools out there from the guys over at Win or SysInternals, which was acquired by Microsoft. They've got various tools to make user mode applications run as a service behind the scenes. I did see a question that came through here. Question is, does an ESX VDR restore require a vSphere license? Essentials are higher, or will it work with a free hypervisor license? That is a very, very good question. So to do recovery with the vStorage API, it does require a licensed hypervisor, so essentials are higher. Same limitations or requirements you'd have for Veeam or other Hyper-V host-based applications. So to do the backups at a host level or to do restores at a host level through virtual disaster recovery, you have to have a valid license. If you are using a free ESXi, then you could get around that by using the bare metal restore functionality and piping the USB stick through to the underlying VM and booting up like it were a physical machine and do a bare metal instead of a continuous restore. You could back up those machines by installing the backup client inside of each of the guest operating systems instead of installing it and talking to the ESX host. So there are definitely workarounds. You could also try to do restores to an offline VMDK file. However, that VMDK file is going to be created as a workstation compatible VMDK. You would have to use VMware Player or VMware Workstation or something to ingest that or inject it into the backend vSphere environment, command line, what have you, and convert it into something that could be mounted by the ESXi server. Okay, hopefully that answers your question, Jonathan. But that's a very good one. I normally do talk about that one. I apologize that I did not. It might be on a slide here later from a comments perspective. Let me check my timestamp here. I want to make sure that we're on target for this. I want to try to get as much content in, but I will adjust it dynamically based on questions that come in. So I don't want you guys to feel like I'm talking just to a deck. I want you to see the problems, the errors I come into, because occasionally I will have errors, and how we go about troubleshooting those as well. Because if you have the error, you're going to want to know how to troubleshoot it in your environment. So let's assume a situation like this where this particular machine right here was last restored 5 hours ago. Let's talk about ransomware. There's a downside to having a standby server sitting there that's up to speed or up to the moment of the last successful backup. Let's assume that the system was ransomed sometime yesterday, but the backup software, for whatever reason, still ran. It didn't completely encrypt the entire server. It only did the document files and pictures and business documents on the system. So you've got all these encrypted files, but the actual operating system is working. Well, that could leave the backup software working. And last night it did do a backup. It managed to back up all of the encrypted data, and it managed to turn around and restore 5 hours ago all that encrypted data to that offline virtual machine. Well, that's just kind of killed my recovery capabilities. And then when the customer comes to me and says, "Hey, can you spin up that standby machine we've got? Because I'm going to spin it up, and it's going to be in the same situation, the same problem as their production system, or maybe it was a bad patch." A bad driver that was applied due to a Windows update on or around Patch Tuesday. Well, it restored that patch, that update to the standalone machine, and when that standalone machine tried to boot, it applied those updates, and guess what? Now it's bricked also. Neither machine will come up to a login prompt now. They get a blue screen, or they get a black failed to start error when they begin to run. So in those scenarios, what do you want to do? Well, you want to come in and you want to right click, or so you want to click and turn off the continuous restore. And then you want to be able to right click and hit force restore. And now you can see all of the available restore sessions that you can roll back to get to a known or a prior good point in time. So I can come back to the 13th, and as you can see, I'm backing up about every 15 minutes here. So I've got a lot of restore points available. I'm going to come back to the 12th and grab a restore point there, and I can hit OK. And that's going to start a restore, but it's going to be a delta restore. It's going to take this virtualized environment, roll that VM back to that prior known good point. It's not going to be as hefty as blowing the VM away or needing extra space to restore the VM in parallel. We'll just create a delta disk of all the changes that we need to restore to roll it back. And then as soon as that restore is completed successfully, we'll merge that delta or that differencing disk in with the current production disk that's sitting there from 5 hours ago to make it look like the one from 2 or 3 days ago. Does that make sense to you guys? You following along? All of my session history is showing up over here on the right. Did the restore work? Was it successful? When and why and how? So that diagnostic information is here, but I can right click on these as well and say launch backup manager. And if I do that, it's going to give me a graphical view of the backup client. You know, the backup manager I'm used to seeing day to day when I'm doing my backups. I'll get that backup service initializing. I'll get connection to localhost, but not localhost 5000. I get localhost and a random port. Because it's doing multiple restores, it generates random ports for each of the restores that is running in parallel. How many servers can I run in parallel? So in a scenario like this case, I've only got a handful of machines throughout the day. I could have 2 or 4 of these running at a time probably, and be able to keep everything nice and consistent. But if I had 50 or 60 machines in here configured on this hypervisor, then I might want to have at least 10 or so that can run in parallel from a restore perspective. The default setting is 5 parallel restores, but you can adjust that through a setting in the recovery console's config.ini file. I'll show you where in the documentation some of those settings are here in a few moments. A good rule of thumb, however, is going to be to look at your number of processors or available cores or hyper-threaded cores, I guess, if it's a Hyper-V machine. But look at the number of available cores or processors, and look at it in N-2 type of structure. So if it's a quad core machine, 2 parallel restores. If it's a 8 core, 6 parallel restores. If it's a 12 core, probably 10 parallel restores. This hypervisor I'm running here has got 40 virtual cores. I'm not going to run 38 parallel restores, so I think I've got it set right now maybe to 10 or 12, something like that, and that's more than sufficient for my environment. It's not only about the number of cores and processors, it's about the amount of available RAM, how many machines you're going to be able to bring up and test at one time, or how much you fail over and run at one time. because when we test, we build it with 2 CPU cores and 2 gigs of RAM. But if you want to test it in a more production-like environment, you might bump that to 4 and 4, or 8 and 8, or 8 and 16 to give it the same kind of power or similar power to the production system. And if you've got multiples of those running, it could reduce your ability to do more parallel restores. So keep that in mind, some balancing of failover power and parallel restore powers. I can't give you the exact number. I can't say to go small, medium, or large in your hypervisor. You're going to have to do those calculations yourself based on the customer and their needs, how much of their failover of their protected environment needs to actually fail over at one time. If it's everything, you're going to need a hypervisor that can handle everything at, say, 60% or 80% of performance, and it can be fairly hefty and fairly expensive. Yeah, so comment here. So yeah, if there's a lot of data that got encrypted, it's still going to take a while. You're absolutely right, but the ability to roll it back is still going to be faster in a lot of cases than blowing it away and building a new one, and it would be safer from a disk space perspective. You don't have to blow this away or try to have enough space for both of them to be restored in parallel. You roll back to one point, and that didn't work. Then you go back and select another, roll back to the next hour before or the day before that, and just slowly roll your way backward or forward to get to the right structure. We could adjust a couple other config.ini settings, those parallel restores, and create that down to just 1 or 2 restores at a time, and then control the delay. How long does it wait to check for new updates? So you can set a 6-hour delay with a 2 parallel restore, and pretty much can guarantee that you're going to be 24 hours or more behind your last backup. So that way you've got a little bit more of a buffer, and then you could always choose to roll forward if there is a newer session. You could put a day's delay or a 2 days delay in here and have a 2-day-old virtual machine and just force it to roll forward if you need it to, or maybe boot it and just do a file and folder restore to roll some of the data forward. So lots of other options there. We do expect to make that even more granular for you and be able to break out different options, different what we call recovery plans for you, but right now you are kind of bound as the recovery console as a whole because each of them acts as its own kind of standalone instance, if you will. So we can see it's scanning. I've got just my restore tab, continuous restore. The restore tab, you can see I can go in here and do my configuration or pick my timestamp if I wanted to. Continuous restore is only going to show me the settings that were configured here in the UI. But you can see all my sessions, pick what I want to restore, where I want to restore to, and how, and all of those kind of pieces. I could configure file and folder restores or system state restores as well as virtual recovery through here. So you get a lot of the options, but we will lock a couple of them in here because they're controlled by the wrapper, the recovery console wrapper as a whole. You can configure preferences like your local speed vault, different credentials to access different volumes, languages, some of the advanced settings, your temporary folder paths and things like that. But we scale it back quite a bit. There's not a lot you have to do here. You can even come in here and click and do a connection test to see can this phone home and talk to the cloud. If you can't get in this way and it's not communicating or you're getting web dev errors, then you know you've got a problem with your networking. Work that out first before you go any further. So on this connection test here, it's getting 258 megabit download, 275 megabit download from the storage nodes in the home node, and uploads around 150 to 160. So restores for this one, once it knows what it wants to restore or how it's going to rebuild that point in time, then we should see some decent transfer rates here, and this guy would roll back pretty quickly. Okay. So let's do a quick time check here before I go into some more of those pieces. I want to switch gears just a little bit. And there is a lot more I could talk about with the recovery console, and I'm happy to answer questions if they pop up. Feel free to drop them in, but I don't want to shortchange you guys from a fail back perspective. And the bare metal side took a bit longer than I was expecting in my AM session, so I want to start that now and take you through some of those pieces. So we'll do a little bit of that Julia Child thing. We're going to put the casserole in the oven now, and we're going to switch over to the one that's already been baking so that we can start to worry about plating and serving. Okay. So we're going to step out here just a little bit. I'm going to go back to my presentation, and to cloud recovery, reactive recovery, bare metal recovery. So bare metal recovery, I could have used this initially with Bob. If Bob had called me and said, hey, I've got a hard drive failure, my entire system is down, and I've got a new drive sitting right here, I could roll the tech out there, plug the drive in, and started a restore with his local speed vault in place. Given the size of the machine, I'm pretty confident I could have got it restored within the hour. I would have done that. Maybe it would have been an hour and 15. I would have gotten his buy-in to say, hey, it's gonna take a little bit longer than that. How do you feel about that? Because it saves me time later. But in this scenario, we're going to use bare metal recovery as my failback medium. So we're going to boot either using a USB stick that we create with an executable. It's available for download, or we're going to boot up to an ISO image that you would burn to CD and drop into your server. However, in my scenario today, I'm going to take the ISO and just mount it in a empty virtual machine inside of Hyper-V, so that way we can share it in the screen. I can record the screens and we can access it remotely and make it a whole lot prettier than me pointing my webcam at a laptop sitting here while I try to deal with typing in encryption keys on that keyboard without knocking the webcam out of the way. The procedure is exactly the same. I'm just swapping out physical hardware for virtualized hardware. We can support dissimilar hardware. We could choose to recover everything during bare metal or selective volumes or data. We'll talk about the reboot as well. It's very important, though, from a media creation perspective, that you do download the executable to create your bootable USB stick, or that you download the ISO if you're going to burn it to media or mount it into a hypervisor, including hypervisors we don't officially support, like maybe a Nutanix environment. You could mount that ISO image and use it to recover into a Nutanix as a bare metal recovery environment. The tools are unique here for a reason. The USB stick is a read-write structure. We write to this extra space on the stick for caching purposes, driver purposes, things of that nature. The ISO file is read-only. And so in that environment, we're utilizing a RAM disk, and you don't want to end up trying to buffer everything to a 4 GB RAM disk. So when you boot up to ISO, we allow you to mount or attach to a network share to act as temporary write space for logs and registers and drivers and so on. So use the right tool for the right type of recovery. Do not use tools like Rufus to burn the ISO image to a USB stick and then boot. 9 times out of 10, when I get brought into a CSAT environment where customers have had slow disaster recoveries or problems, it's been one of their very first recoveries, and they've done exactly that. They've used a third-party tool to burn the boot media onto a USB stick. So I do have a recorded video version of this. We may have to go back to it if time requires, so I can show you various ending steps here. We can time lapse through a few things. I don't want to do that if I can help it. I want to take you through the actual hypervisor and get this up and running. So we're going to go back over into Ivy here, and I'm going to come by up here to this bare metal recovery BMR ISO UEFI. I've got a BIOS version. I've got a Gen 1 and a Gen 2. So 4 different machines here that are configured with some disk and some RAM that I can use for bare metal recovery. Gen 1 and Gen 2 type systems. I'm going to go ahead and turn this system off because we want to utilize this guy. So let's look at him a little bit and see what he is. We're going to go into settings, and I've got a UEFI-based virtual machine configured here. It's got 2 virtual processors and 8 gigs of memory. It's set to boot from the DVD drive. The DVD drive is pointing to a bare metal recovery ISO image. I've got a hard disk down here as well. I've got a virtual switch set up with my network adapter. I've got everything set up the way I need it to go. I do want to boot from my DVD first. I'm not using secure boot or anything of that nature. You could change the priority order here and things like that if it's in the wrong position. It's not just about selecting it. You have to actually move it up in the order. I've learned that a couple releases ago. I, for whatever reason, thought me selecting it was going to change it to the one I wanted to boot from. And then it was just, for whatever reason, would not boot from that environment. But this is going to be different versus if you were running in the BIOS environment where you won't see these different EFI streams. Please note that if you were backing up a machine that was a BIOS uh, MBR type configuration, then you need to bare metal recovery it into an environment that's configured the same way. I can't convert or change it on the fly during recovery. There are methodologies out there from Microsoft to convert from one to the other. I have to convert back to the way it was originally protected. If we detect that it was configured differently or wrongly, I will present that information to you during the bare metal process and say, hey, you booted into the mode, into the wrong mode based on the last backup sessions that were done. Okay. So let's go ahead and hit OK on this guy. We're going to go ahead and start him. And I'm immediately going to try to connect because I need to get that prompt to press any key to boot from CD. So I think I made it. We'll see for sure here, because I'm going to be presented with a boot menu from my bare metal recovery ISO. So what you're going to see here is a command prompt or a command menu come up, I guess. This menu, it lists the version number of the build for bare metal recovery. I'm using a ISO image here from January of this year, so it's a few releases old, but it is going to work just fine from a recovery perspective. We haven't made a lot of significant changes to the BMR process, so it's not like you need to go burn new ISOs or redistribute USB sticks at all of your customer locations. There's only going to be a couple times per year where you might have a need to update the recovery image. Obviously, if you can use the latest and greatest, by all means do that, but you know, as you can see here, not a requirement. If I hit 0, it's going to take me into the backup manager where I'm going to enter my device name, my password, my encryption key, and start my restore. But before I do that, I need to set up some of these or test some of the environment right here. I need to purge my disk, make sure it's nice and empty and clean, so that I don't have any residual information from my earlier bare metal recovery session this morning that we did. I want to make sure I've got network connectivity that can get to the cloud, and I've got my network path for my additional drivers so I can load those for dissimilar hardware. I'm going to turn on and start the VNC process so I can actually remote into this recovery session from a VNC browser, a VNC player, VNC Connect. Anyway, from a VNC client. There we go. That means I can get away from having to stand in the server room. I don't have to, you know, be ducked down or crouched in or you know, sitting next to a mop and a bucket and a networking panel. I can open VNC server here, come to another machine in the network where it's not noisy, and it's not hot, or it's not cold, and then I can remote in and actually finish and configure this bare metal recovery. It also means I can now copy and paste my encryption keys, device names, and passwords into the screen versus typing them into that really crappy old keyboard that's missing a foot and hanging off the side of that rack in that server room. You guys all know what server room I'm talking about, right? I think. So let's go through and do a little bit of the prerequisites here. I'm going to show my adapters, option 1, to see if I've got a network connection, a NIC. That means my drivers loaded the NIC. That's great. If it didn't load the NIC, I'm going to have to go back and try some other options here to get my NIC configured inside of the VM or on the physical hardware, I may need to you know, do some magic here to inject it. If you're running the USB boot, you inject the drivers in at the time you create the USB stick. That is one of the differences. One of them you proactively inject the drivers, the other one you reactively inject the drivers from a network path. But I've got a network path, so that's great. Now I'm going to get my current IP address. That's option number 2. You can see here it grabbed it through DHCP. That's great. If it did not, I could do option 3, which allows me to configure my LAN, and I would set up my stack IP addresses, my gateway, subnets, and so on. You do need a wired network connection for this. It does not work with a wireless network connection. While Windows PE can support it, it's a little problematic, a little difficult to configure. We obscure or we hide that functionality here. If you need a dongle to connect to the laptop to network, or you're using a docking station, you may need to load drivers into the environment to do that in order to get full access to network connectivity. You might also need to load storage controller drivers for your RAID array. You might need to load chipset drivers to get faster access to USB 3, things of that nature. But just a few different drivers. You don't have to load every driver that's available for the given hardware machine, but you will want to utilize drivers designed for Windows PE or a Windows 10 based environment. Okay, our bare metal image or our boot image is tied to a Windows 10 instance. Test the network configuration. That's going to be option 4. It's just going to ping the home node or the cloud service. We can see we can get out here. It means I don't have to configure a proxy. I don't have to go open up GeoIP, blocking, things like that. I don't have to go fiddle around with the switches or the network cables to make sure I'm actually on a live network or on a live port. Now that I've got network paths and IPs, I can map my network storage location. This is a place to write logs, to write my backup register, and to drop additional drivers to load into this instance. So that's option 5. And we're going to create a network path here, which is going to be mapped to drive letter Y with these directories for use. And this is where it's going to write that temporary information versus trying to put it into that 4 gig swap disk. Okay. So we're going to go hack IV / backup as my network path, and I'll go IV / admin administrator. Yep. And that should give me a network connection now. I can test that by coming in and starting a command prompt. And you see it created WinPE on an X drive here. This is my Windows environment, CD / and get a quick directory. So I can see program files, users, and Windows, a very basic Windows PE installation. I can go to my Y drive, get a directory of this. This is just a mount point on the server, so you can see I've got some additional files and directories here, like ISO images and firmware updates, and my local speed vault is here. I've got my seed drive here, a temp and a working folder, as well as those additional drivers and debug datas and volumes or paths created by that mount point. So for instance, if I were to go into backup register storage here and get a quick directory, you can see that I've done bare metal recovery before for server 1, server 2, and server 3 in this particular environment. So I've got some directories that are in here. Those are either going to get updated or replaced here in just a moment by new data coming down or temporary data coming down. My log files are going to be in here too for previous restores. So if I go into CD debug data and get a directory of that, you can see I've got dumps and logs here, and this is great for troubleshooting. If you have any problems, those logs are going to be in there. Bare metal recoveries are already doing debug level logging so that you don't have to go back and turn that on and then recreate your problems. You can just provide that log directly to the support tech if you have an issue. Okay, so we can, while I'm in this command prompt here, I'm going to do another thing here called disk part. So disk part allows me to do partition management and clean and wipe disks. So we'll do, first off, we'll do a quick help here. And I'm going to then come back and list my disks. So I see one disk, disk 0. It's a 256 gigabyte disk. It's what I provisioned in my hypervisor. It's currently using 129 gigabytes. I'm sorry, it has 129 gigabytes free, and it's formatted or configured GPT. So what I'm going to do is I'm going to select disk 0 as my focus disk. And now I'll do list disk again, and you can see it's now got a focus with the asterisk. And I'm going to come in and I'm going to clean that disk. This cleaning is going to basically wipe that partition table and structure so that when I go to do my bare metal recovery, I'm not working with a disk that's got visible data on it. So no smoke and mirrors here from that perspective. I don't want to, have a disk that's already got information on it and not actually transfer data. Okay. So now that I've done that, I can do list partitions, and I get no partitions. I can do list volumes, and the only volume or drive letter I have is drive D, which is my CD-ROM or DVD-ROM image for BMR 21.1. Notice the label of the boot media also has the version number for the recovery software. So that way you can see when you run it, or the label of the USB stick or of the CD or DVD, you know exactly what version it is without having to dig into it too deep. We'll exit this part now, and we'll exit the command prompt. Now, if you get really happy and you're hitting X's to close this, you accidentally close this prompt here. Every time you close it, it does reopen it, so you can't get rid of it. It's going to stay. Other options down here. I could drop drivers, INF files, into that additional driver's location, and if I have those, hitting option 6 will go read those and load those into the environment now so that I can get to my disk, load my storage controller drivers. So maybe I would have to do that to load a storage controller driver, and then I might need to drop back to a command prompt in order to go in and do some type of disk management after I can see that array It really depends on whether you're working with a system that has a BIOS controlled, hotkey controlled RAID configuration, or whether you have to run software in order to do the RAID configuration from a command prompt before you do the restore. I'm working, these hypervisors here at least are Dell R720XDs, and they've got your PERC controllers in there. So it's just a Control S or Control D or something along that when you boot in order to provision your disks and create your virtual disks and present those out to your operating system. So if you needed to build or configure multiple drives into an array, you're going to do that at boot up before you boot into the bare metal recovery media. You'll do that while it's doing its post and its diagnostic. Go in and configure your disks and then boot into this bare metal recovery environment. Okay. Other things to think about, if you've got multiple disks and you only need to recover data on one of those drives or one of those volumes, my recommendation would be to either physically disconnect, unplug those volumes, or at least go into disk part and verify that you are connecting to the right volumes. Make sure that disk 0 is really reporting as the right disk. It's the actual boot drive, that it didn't swap or mix up any of the boot order while you're running in this Windows PE environment, or that a USB stick or that an ISO image didn't cause a phantom DVD drive to take a drive that would have been normally used for something else, those kind of things. It's going to help ensure that you recover the data to the right volumes, and you better do that off up front than to have to deal with that after you've accidentally restored your disk 0 or your C volume over top of what was reported as disk 0, which was your data volume. Okay. There was a question that came through here. Do you currently have any scripts or other tricks to proactively mitigate against BMR's inability to restore 8.3 file name references on NTFS volumes? It doesn't even currently enable the NTFS flag on the volumes. It creates to allow them to support long file name. I do not. I don't have a process for you on that one at all. I know it is an open issue. It's with Ron, one of our senior product managers. I know they was trying to bring that into a sprint here recently, but it was deferred for some reason. It may be part of an active sprint or an active effort right now. I'd have to find out for you on that one if you like. If you want to drop me a quick note in via email, you can grab my email address out of the console or out of the GoToWebinar. Drop me a quick email on that one, and I can see if I can get a status for you from product management and or development on where that enhancement or feature request is. But yeah, in this particular scenario, you're right. We're not laying back down the 8.3 names. And if you did come back and turn that on retroactively, it could recreate an 8.3 name, but it's going to create it on the fly, not based on what it was originally on the original system. So I don't see a lot of issues with it, to be honest with you. It is a very rare occasion that we run into a problem tied to an 8.3 name, but even one or two there, it's additional troubleshooting and have to recorrect. So yeah, I understand why that could be a problem. Yeah, I wish I had a way around it. I've been pushing for 8.3 for quite a while. Honestly, back to the time when I was in product management. It's one of those things that getting enough critical mass for it, prioritization for over other issues, whether they be security or recovery or what have you. But I know it's come up, in each of the triage meetings for the different releases, and they've been trying to get it squeezed into the actual release. Probably the same team right now that's working on the recovery console replacement. So that may be part of the slowdown on that one. They've got to address it for the new update or the new build, so it takes them off, or it's probably delaying them from one while they're working on the other. But we really have to have it for recovery testing and the new replacement as well, in my opinion. Hashtag forward-looking statements. Other things here. So we saw the command prompt, check and repair boot settings. This option is available to you. It's the equivalent of start rep on your Windows boot CDs or installation CDs. This is going to allow you to fix the boot record or boot environment, both UEFI and BIOS configurations. The option 9 here is available if you're utilizing different keyboard layouts, if you're not primary English speaking first, where you're utilizing a international keyboard layout. You can change your keyboard layout. This is really important if you've used keys on a non-US keyboard to generate your encryption key. So being able to map that keyboard and connect properly so you can get that encryption key entered versus copying and pasting it in can be very critical. Additionally, there is that option for starting VNC server, and that's as simple as just running option 11 there. That's going to start the VNC server behind the scenes. The password to connect to VNC is going to be VNC password. The IP address for it we get up here under show current IP config, which is option number 2. And you can do that from any VNC client, and allows you to, like I said, go back and work at a desk in a air-conditioned or a heated room versus that server room, okay? And great if you need to talk to support where maybe you don't get reception in there, those kind of things. The last option to reboot, we're going to save that for when the recovery is done. So I'm going to hit option 0 and proceed into my bare metal recovery. We're going to do a couple quick steps here to get this restore started before we take our first break, and then we'll do a break while it's doing its manipulation and data transfer. I need device name, password, and encryption key. I'm going to bring up my console right here so I can grab that credential information. This is for server 02. So that's the system right here. We're going to go into the modification tab. And you can see right here, I've got the ability now with the recent update, I've got copy icons here to actually copy it to clipboard directly versus me having to highlight it. And then the ability to generate my passphrase because it's managed by the system. I'm going to pull these out of the way so I can use them on a different screen while I drop them in over here. So we're going to go with device name. Because I'm coming in through a hypervisor, or because you're coming in through a VNC, you can come in here and paste it. Maybe it's Control-C, maybe it's Control-V to copy and paste. But if you're in a hypervisor and you're nested a couple layers deep, sometimes you have to go in and actually use the tools to say type clipboard text to get the data to go in. And that's my situation here today. So we'll do that, grab a copy, and then we'll go in here and paste. It's going to validate device name and password. Those are owned and controlled by the system. Then you need to go get your encryption key if you manage and keep it yourself, or you're going to go copy it from backup.management or in Central or from inside of RMM. And we'll come in here and we'll paste this one as well. That looks right. And copy and paste is your friend here. That's a 36-character string if we generate the key, and it's blind entry if you notice. So if you mess up on that, you could be entering a couple times to try to get it right. So even more important to have that keyboard layout set properly. So it's going to validate my credentials here. It's going to start to download my backup register, and it will present me with a light version of the Backup Manager UI running in a Mozilla or Firefox browser under or inside of Windows PE. Now this backup instance, or this restore instance, is already configured with 10 restore threads and configured with debug logging turned on. So there are some help articles and knowledge base articles that talk about increasing thread count or turning on debug logging. You don't really need to do that in this type of scenario unless you wanted to go above and beyond that default 10 restore threads. If you had gigabit fiber, for instance, and you wanted to bump it to say 40 or 50 threads, then you should be able to take advantage of a lot more of that available bandwidth. Around 10 threads or so, you're going to see, maybe 100, probably best case 150 megabit type downloads, and that's only going to be if the system can handle it. If the disks or the memory or the processor or other I/O is too constraining, then we won't be able to pull at those speeds. We're going to buffer around 500 megs of downloads and cabinets while we're doing the restore, but we don't stream data down. We're going to pull it as we need it and then rehydrate that deduplicated data as we decrypt it. Okay. So this is trying to initialize the backup service. This took a little bit longer than I was expecting a little earlier today too. So I think I've got something going on in my environment. I need to go troubleshoot, or it may just be time to give up on this particular 2012 hypervisor and upgrade everything to the latest and greatest. But I wanted to show the fact that you could utilize not just 2012, but or not just current stuff, but older systems as well. I've got a 2012, a 2016, and a 2019 here, but maybe I do need to refresh all of those and move them to a little bit newer. While this is trying to load here, we do want to check and make sure that things are still working properly. We know we had an IP address, so that's great. We know we were able to phone home. So I'm going to minimize my browser a little bit, back to my command prompt, and get full screen here. You can see I've got it down here still if I need to get back to it. Let's do a command prompt real quick and see what's going on. So a little troubleshooting here. So we'll go to a command prompt. We're in here, we're going to go task manager. So now I can look at task manager to see processing. So here am I running processes. I'm using 12% of my memory, 1% of my CPU. I'm not beating the system up right now. Services, performance. I've got some CPU utilization, but not much. Memory is almost all free. If I go to networking, it's referencing a 10 gigabit pipe because of the way my virtual environment is set up. It's only gigabit fiber to the cloud, however. So whatever you saw here, a tenth of that. But even there, I'm not even hitting 1% utilization right now. So it is trying to connect, but it's not really getting much of anywhere just yet. So we can watch that and see what's going on. But yeah, same issue I had a little bit earlier today. I gotta have something that's causing some other issues here, but it will catch up, I promise. Let's take a look at that Y drive real quick. So if I go in here and I'm gonna go into CD backup register and get a look at this. I've got my backup registers. Let's go into CW 2012R2. This one right here. And dir/s. This is my backup catalog or my backup register. Let's see, it's currently what, 427 bytes and 427 kilobytes in size, 439. Okay, so it is growing. So that means it is downloading data and updating the backup register, which is what it's trying to do to get session history and catalog history. And I've been doing backups every 15 minutes for quite a while, so it does have a fairly large dedupe catalog and session history. So maybe that could be part of it. But let's see if that's going to continue to update here. It looks like it may have, so the size is standard, but my free space is still changing, is shrinking. So it does create sparse files here and it fills in the data behind the scenes. So you can see my free bytes are currently dropping as it's populating data into that environment. So that's good. Let's go back and check on my backup manager and see if it's functional yet. Okay, good deal. This took a little bit longer than I was expecting. I'll work on that once we get the environment a little bit more pristine. But I don't want it to be too pristine. If this thing runs super fast and it restores a system in 5 minutes and you're back up and running, that's great. But that's a lab environment. It's me utilizing SSD to its and gigabit fiber to its best, and that's not the way your customer environments are going to be laid out. I kind of want you to see some of these edge cases and some of these failures so that you know how to address them when you get into those situations yourself. So here's the backup manager. It gives me a couple different warnings or notices here in yellow. If I was in the wrong UEFI or MBR boot mode here, it would tell me that now based on settings. You can see the name of the device that we're recovering, the name of the machine that it called the system while we're in bare metal mode, and it grabbed a dynamic IP address so that way it's not going to conflict with the production server Bob's using right now, that Failover VM. It's running version 21.1. That's the version of the backup manager client that is on that BMR boot CD. Even though we are now 9 versions behind the production 21.10 release, that's fine. It'll still work for this situation. If you can get within 3 or 6 or use the latest, by all means do that, but don't feel like you have to always. If you have failures, however, then yeah, one of the first things, go grab the latest and greatest. That's one of the first things support's going to ask you, so you might as well try it before you call in or you open that ticket. Current product all in, a connection test. This is another phone home. If you get any type of web dev or other connection issues in here or it times out, there could be some quality of service throttling, or there could be a proxy or something that's blocking your access. I'm seeing only 8 megabit upload, 72 megabit download from my home node. That's where I'm getting the backup register from right now. And I'm seeing 220 megabit download from my cabinet nodes. So hopefully I can take advantage of most of that available bandwidth to do my restore here in just a moment. And we're at 5 minutes after, so I want to get this configured just a little bit further, and then we will break and we'll let it watch the do it restores during the break process. Okay, I'm going to come to my preferences tab. I can configure my local speed vault if I had one in place. I don't actually have one configured for this system, I don't believe. I tried it a little bit earlier today, and it was just saying 0% synchronized. So I think I've got a container, but I don't think I have anything in it for this particular server. I probably picked the wrong server to demo. So we're going to do all the data restore from the cloud, which once again is something you could come up with. So when you're adding a vault, however, and I'm going to show it to you, even though it's going to show synchronized in 0 here, we're going to go hack instead of going IV/speed vault, which is going to give me a conflict because I've already mapped that IV network path with a different end point using for my my network share a little earlier. So to get around that and the conflicts that Microsoft's going to give you, I'm going to use 192.168.0.204, which is my IP address for IV/speed vault. And then for my user here, that is going to be IV/administrator. And we'll drop in my speed vault password. So now it's initializing the speed vault. It'll tell me what percentage level it's synchronized at, or it'll tell me whether it's failed or can't connect or can't connect. So it is synchronized. It is showing that it's synchronizing, but it's showing also a 0% complete. That means that I've got a container. You can get to it, but there is no data in that container that's tied or synchronized with the cloud right now. So you know, maybe I blew it away. Maybe it's part of a cleanup process. Maybe I turned off the speed vault on the production system, and so there is not anything but an empty container here. Anyway, even with this here, I can still attempt to do my restore. It's just not going to find anything, so it'll pull everything over my gigabit fiber. Restore tab. What session do I want to use? I've got multiple sessions I can work with here. I'm doing every 15 minutes or so, so you can see I can grab any one of these that I want. I'll grab this 10:48 p.m. one here, for instance. What do I want to restore? I'm going to do the C volume only. In restore mode, only the volumes are selected for restore, and I will inject any drivers that I loaded into the bare metal recovery environment into the final created virtual machine or physical instance here, or technically virtual physical instance. I can open a command prompt if I need another one, open my disk management if I need to do that again to monitor, and I can show log files while it's doing the restore in real time. So we'll trigger this, and we'll say, yes, we want to continue. And we're going to let it start its restore process. So given that it's about 8 minutes after the hour, I'm going to bring a timer up, but I'm going to leave it on this screen so that you guys can watch this. I don't want to switch away from this unless we're talking about other topics. So that way you know I'm not swapping those casseroles out on you until we absolutely have to based on time. It's downloading the backup register still. It's going to take me through 5%. At 6% is when it's going to start to build the disk configuration and lay down actual files. Up until that point, it's just identifying changes and trying to identify how much actual data needs to be transferred to rebuild this system from scratch, okay? While this is doing its thing here, we can see it is processing through. It's identifying a number of changes. These numbers are going to grow typically exponentially as it's identifying what it needs to restore, what it needs to rehydrate, how much data there is to transfer, things of that nature. I did mention it was being a little bit slower today than I was expecting based on prior boot camps that I've done, but hopefully we'll see it pick up here in just a few moments. The percentage that's here, when not in the scanning state, it'll show a current percentage of the restore. That first 5% is going to be this preparation phase. Once you get to 6%, that's going to be the initial start of disk configuration and disk provisioning. And up until the point we get a single file processed. Once we've got a single file processed, then it's going to move into a multi-threaded restore state, and you'll start to see the actual number up here, 0 of X, start to count up. And you can turn on the show charts option here and watch the queue size of data left to be restored start to trend its way down. And that's just by clicking on this percentage bar once it's back into an actual percentage and not scanning. While that's working though, I did want to actually just follow up a little bit on one of the queries that you'd had, Jonathan. So on the 8.3 side, I know that I can come in and query the state of 8.3. So like inside of Windows PE here, I can, let's see, try to find out whether Windows PE has 8.3 turned on or not. So clipboard text. Okay, so FSUtil 8.3 name query right now is telling me that the registry state is saying that per Windows PE, we're using per volume settings, which is the default option for 8.3 naming. And let's see what we can do. I guess technically after the C volume is created and provisioned, you could drop to a command prompt here and manually run the FSUtil instead of doing a query, set a value, a value of 0, I think, which is going to, turn it on for all volumes. Let's see if that would work here. I don't have the volume created yet for C, so can I turn it on for a volume that doesn't exist yet? I don't actually know. Type clipboard text. Behavior set. Okay, registry state is now 0. Enable 8.3 name creation on all volumes. Once again, I'm running inside of Windows PE here. I'm not running on the production system, so I don't know if me changing it and addressing it here in a Windows PE perspective is going to help me at all in the reestablished or laid down operating system or not. Still, it's going to be a case of the fact that we're not capturing and storing a database entry of the long and short name that's utilized up front. So even if we were to rebuild it here on demand, the problem you'd run into is that two different files that share the same or a common prefix for their 8.3 name, tilde 1, tilde 2, tilde 3 type of approaches could be in a slightly different order. The fix, from what I understand, that development's working on is a additional capture during backup scanning that would store the 8.3 state as well as the 8.3 name if it exists, and be able to lay it back down and create it with the exact original name that it had at the start and put it back into the same state. There's other problems that we run into here too, in the sense that the default configuration is that normally it's only the C volume that's going to have 8.3 naming turned on. The data volumes are typically going to have it disabled. And that means if you do any redirected restores from files on the C to a D volume, you lose your 8.3 name that way. So redirected restores are going to be a little quirky. And then of course, just being able to pull an index of it and know exactly who, what, and where. I've got your information though, so I will let you know what I'll follow up with you via email, let you know what the status is of that one. This is honestly important for anybody else on the call here too, because it is it is a known limitation of the process. Although, like I said, I see it come up maybe once in a blue moon, twice in a blue moon. I don't even hear about it on a quarterly basis, so it's not something that is as large of an issue as it would have been back in, say, the server 2000, server 2003 days. Let's see what else is going on here. We're going to minimize these guys, and I'll bring my environment back up. So I am still scanning 157,000 now, 159,000, 161,000. So we're moving, what, 2,000 or so at a time, give or take, 1,500 maybe. So this is moving right along. I think the sweet number here is going to be 203,000 files. If you really wanted to know how many files it has to count up to in order to do the restore, you can go over to back to your overview tab and look at your backup history. And you can see here in your backup history, how many files did it back up the last time it actually ran a job? Well, it had 205,000 files as part of the file system backup. I'm going to be somewhere near this 205 something when it finishes processing the count of what it needs to restore, since I'm restoring the entire set of data. So yeah, almost there. We'll then move to our 6%. We'll see it starting to lay down the disk structure. At that point, we can drop to disk part and actually see disk creation and things of that nature. I will occasionally walk around the file system while it's laying down files and structures. One of the things you'll notice while it's doing that is it's going to create the entire file tree structure first before it lays down the data. So that first 5 to 15 minutes, 15 minutes to an hour, if we're talking about multiple terabytes and tens of millions of files, that first percentage, a first good chunk of transfer is going to look a bit slow. You're going to see some really odd estimates as it's going through and creating all of the directory structures, because there's no real data transfer at that point. It's just building a tree structure in order to drop the data back into. And permission structures, it does preserve your user permissions and inheritance from your NTFS backups, or I guess FAT and FAT32 backups. We preserve any type of ACLs that exist inside of that structure, and we lay those back down during the restore. So that's why we see a 362-day estimate right here while we're in a single-threaded disk configuration structure. One file is processed. Even after it finishes creating the disk, it's still going to be stuck right here on this status until it finishes with the directory tree structure, and then you'll move on. You'll actually see the real file transfers happening behind the scenes. But you can now click back on this percentage bar, and you can see we're 13 minutes into this. It's only really transferred a very, very small amount of data at this point. It's been prepping and building its inventory of what it needs to rehydrate, which cabinets to restore for which files, which ones it's going to download and preserve while it's working on other files, what order it's going to restore the files in, so that it takes full advantage of any type of cached data that's been coming down. The goal here, just like with data dedupe on the backup side, is to never send the same data across the wire twice. We don't want to download something and then turn around and say, oh, I need that again. I have to download the cabinet again because I threw it away. So we'll try to cache as much as we can and restore in a optimized order. Cool. We should be able to see the dir/x/c commands. I would think so, but once again, I turned that on inside of Windows PE, not inside of the recovered operating system. So I don't actually know whether it's going to be there or not. You know what? Let's take a look and see. Appreciate the queries, guys. It's always nice. I take these and I embed them into future trainings. Let's see. C colon, is C available? Yes, it is. dir. C is there. I've got some data in C. That's a wonderful thing. So let's do dir/x. Do I need to do anything else here? Let's see. Program files, dir. Yeah, dir/x will display the long name and the 8.3. So yeah, so no, changing it on the fly like that did not seem to make any effort for me. So we'll have to capture the information up front. We'll have to lay this down during the disk provisioning and ensure that it's also injected into the final recovered machine when we do the final reboot. No worries. A lot of the current implementations you see in bare metal recovery were done, when I was in product management, and I built a lot of this, or I hacked a lot of this together for usability and improvements, the default threads, the default debug logging, the ability to expose VNC inside of the UI versus having it 100% hidden. Those kind of things, just because it does increase performance overall. I am working on a few different, I won't call them hacks, but a few different evaluations and trials using third-party tools and third-party bootloaders to be able to do bare metal recovery or virtual recovery for Linux environments. We've attempted it in the past in a couple different beta attempts, but it's never really taken off, never had a lot of real interest in it. But I do want to try to build out with an open source bootloader and CAPS utility that can utilize our backend file process in order to lay down the original disk structure, the kernel, and then we would put the data back in. So other things I want to inject here, I would like to inject a PowerShell module. So you've got PowerShell control inside of the Windows PE. Just sideload that after booting bare metal recovery, probably from a network connection or on that USB stick. And I'm looking at a open source disk-based or PowerShell-based partition undelete. So that way, if you were to accidentally overwrite a partition or structure, you could undelete that partition from inside of the bare metal recovery tool. I have also come across a graphical or somewhat graphical disk partition manager. So you can do graphical partitioning versus disk part and maybe build some predefined configurations or expand your disks and things like that, as well as the ability to take it out of bare metal recovery mode once you've booted into it. So that way you've got the separate installation, the different directories, and you don't have any type of in-use file dependencies on volume C, so that you could choose to restore just a partition and not the entire disk zero. So some other things that I'm thinking about here, my successes and failures, proof of concepts, if you will be going to product management for those examples, and we'll see if we can get those possibly into a future release. Hashtag forward-looking statements. Just trying to keep pushing the edge of this here. Obviously, learning from what we do successfully, from what we fail on, and then what we see in the market with our competitors. So I want to be cognizant of time here. I want to get back into this. Let's see where we're going here from a status perspective. So we're going to bring this back up. It is still talking disk configuration here. I hope I didn't break anything by changing my 8.3 naming structure. I did a little experimentation on the fly there, which sometimes does turn around and bite me. But nothing ventured, nothing gained, right? So we are 19 minutes into this one. It is actually processing files though. Okay, so yeah, it is transferring files now. So we see files processed, 336, 930. So we're dropping these in here, hundreds of files at a time now. So this is going to take on a pretty quick approach. It's estimating 17 minutes to completion. Once we got past that initial disk structure catalog and so on. So the first 19 minutes were really about prep and overhead. And if this was even twice or 4 times the size, it probably would have had that same initial prep and overhead. It's this point forward where we're going to make up the time. Okay. Once again, though, this is Microsoft time. The estimate's going to change depending on whether it's got a great level or a low level of compression and dedupe, and what it's seeing when it goes to rehydrate the data. So you may see it pop up and say, 180 days again at some point if it gets into something really complex. If we minimize this guy again and we come down here and look at my performance monitor now, we can see me starting to utilize a little bit of network bandwidth. Although it's still minimal from a percentage perspective, because we're factoring here percentages based on 10 gigabit connection, and I've only really got a tenth of that available anyway, since I'm running on gigabit fiber here. Let's hit a couple other discussion points and topics here. We'll let this guy run behind the scenes. I'll pop back into him from time to time so we can see how it's going. If we need to bring up the video in the last few minutes to go through and talk about the final closures and final boots and statuses like that, we'll do that. But otherwise, we'll try to get as close to the actual restore point here as we can. And historically, that's been the case. My last 15 sessions have been pretty successful. Sorry, the last 14 sessions. The one prior to this one was also very slow, but the ones prior to that have been very, very successful. Occasionally I'll get a case where I've got vault connectivity issues I have to work around, or I get an environment where it doesn't want to boot properly. I have to run the start rep, which is always a great thing to see because you understand how it works at that point. But they've been very successful, and normally in a 22 to 23 minute entire restore process. That is before I set up 15-minute backups for these devices. Before I was doing just daily or at most every 4 hours. So it could be a case of me just creating a very complex and large backup register, which is having to evaluate a lot of different sessions to rehydrate data from multiple different points in the dedupe store. So I will reevaluate that one, but once again, I don't know about those things if I don't run them and test them. So I can make recommendations to our development teams on that one to figure out how do we stage that one or optimize for that one, the rehydration of that data. But it looks like it's running pretty good right now. As we go back into my environment here, just to recap on the bare metal recovery side, don't use Rufus. Use the USB or the ISO appropriate for your environment. It's bootable into Windows PE, Windows 10. You choose your drivers that you need if you decide you need them for Windows 10. And while you're at it, grab any additional drivers you might need for the operating system that you're going to be running the production environment on, tied to the new hardware. So if you're going from Dell to HP, grab the HP drivers for Server 2016 or 2019 and inject those into the process so they're there after you've finished recovering the data, at least as best you can. Don't inject hundreds of drivers, but work on storage controller, video, and NIC, chipset drivers, those kind of things. Anything else can be picked up post-restore through Windows Update, through plug and play, or plug and pray, depending on how long you've been doing this. It is very interesting technology. It's been improving constantly over the years. I still don't rely on it for everything, but Windows has gotten really good at finding the drivers and injecting the drivers that are necessary in just about all cases. I very rarely have to go do manual driver injection now. Occasionally, it's going to be me putting a docking station driver in for a NIC so that I can get it to work with the laptop that doesn't have actual physical network ports. Or it's a small dongle that's plugging into USB-C that converts to a network port. Getting the video on that external dock to work, things like that sometimes can be a little bit of a challenge, but that's normally the biggest issue. Aside from one issue with servers, HP ProLiant did run a series of servers that did not like third-party USB sticks. So my USB media didn't have the right drivers for it to allow boot on the HP side. So we had to sideload or slipstream in some HP drivers onto our USB boot media so that we could actually boot up and then load the additional drivers for the HP RAID controller on that system. I think that was like a Gen 9 or something like that we were dealing with. Haven't seen that in quite a while. It's probably come up in discussion at least 3 times that I'm aware of, but that's really been it. Occasionally you'll have to preload a Broadcom driver or an Intel NIC to get a more efficient one or faster data transfer, or a chipset driver so that you can get USB 3 speeds instead of USB 2. But even then, that's something we were seeing more when we were dealing with a lot of older systems, and it's less and less prevalent today in a Windows 10. Haven't tested with Windows 11 yet, personally. We did qualify Windows 11 though here with our 21.10 release. So if you're going to be doing bare metal recovery and working and testing in any type of Windows 11 environment, I definitely would suggest the latest and greatest tools and utilities for that purpose. Okay. As you can see, I haven't even updated my slide yet with Windows 11. So that was the Tuesday rollout of 21.10 this week. We can support the dissimilar hardware environment, just control the drivers. There are driver packs. That's where I was going. I lost my train of thought there for a second. Let me bring this up. The keyword for this one, and this is not something you're going to search on the Enable site. This is just a standard Google search or what have you. Bing search. Ugh, I can't believe I'm using Bing. I apologize, guys. So let's go in here. We want to look for Dell and driver pack PE. So WinPE 10 driver pack from Dell. So we'll grab this guy right here. What do we have? We've got WinPE driver pack. I can download this now. It's 126 megabytes. Dell command deploy driver pack homepage. Understanding Dell comparison report. And we've got a nice list of various drivers here that are designed for that environment. Let's go to back again. Let's go HP driver pack WinPE. So here you can see WinPE driver packs for WinPE 10, 5, 4, 3, and 2, client packs, as well as they've got server packs. You can do this for Toshiba, you can do this for Lenovo, a lot of the other different vendors out there. Pulling these packs down could give you a single set of extractable drivers. You don't have to now go get individual drivers and try to figure out how to crack open their exe and install it and find the INF files that you're going to then drop into the bare metal recovery media. However, do me one favor, don't download the entire pack and expand it all and drop all the INFs onto the USB stick. You will cause a failure. If we try to ingest all those drivers into the environment, it's not going to know which ones to try to load and work with and which ones to ignore. You will blue screen your recovery, I guarantee it. So get selective about the ones that you use and make sure you're using the right one for WinPE 10 configurations. I'm curious, does anybody here in the audience, was anybody here familiar with these Windows, these vendor-specific driver packs for Windows PE? Ever have to deal with that? So if so, let me know, or if not, let me know. Just a quick note in the question section there. I keep bringing it up because I keep hearing people tell me that they weren't aware of those. So as soon as I get a good feel that I've saturated the knowledge, then I can step away from it. But until that point, I do want to keep bringing those up. Okay, back to my recovery IV instances. Running along here, estimating 50 minutes now. So yeah, it is slowing down a little bit. Maybe it'll pick back up. We're 25% into it now though, so we are moving along. And getting some network traffic here too. It could be other utilization of my system. Maybe I've got an IO bottleneck. Maybe I'm doing too much SMTP monitoring, too much packet analysis. I don't know. We'll find it out. We'll get it improved, and whatever I do learn from this, I will make sure that you guys are made aware of it. One thing that I know I did take care of, though, that you should think about when we're troubleshooting these things. Once again, I'm playing this up a little bit here. I actually do want it to be slow and have errors and failures. If it is perfect, you're not going to believe that it's a real restore and that things are working the way that they're going to work when you go to use this. You're going to go in and do a bare metal recovery or virtual recovery, or you deal with environments where you've got AV software and things like Threat Locker or Sentinel-1 that can filter your traffic and can actually slow down restores because it's causing additional disk I/O, or it's scanning all the files you're restoring, or it's generating false positives or inquiries around the various things you're doing. Imagine if Sentinel-1 didn't like a file that the backup manager was restoring. Well, is it going to flag the file, or is it going to flag the backup manager that's transferring the file? Well, it's going to do a little bit of both. It's going to identify the file and the process that's running the restore or trying to lay that file down. So there are whitelists that you want to create for your various backup processes, your restore processes, your services, executables, paths, and log locations to help ensure you don't create a 2x or 3x type of disk I/O, memory, or CPU tax during recovery. By all means, you don't want to fully block everything that's being restored. You want to be able to check and test so you don't restore something that is infected or suspicious, but you also don't want to slow everything down to a crawl because of multiple AV products and security products constantly interrogating the backup software. As I said yesterday, the process of backing data up and the process of recovering data looks very similar to the process of encrypting and ransoming and exfiltrating data because of the dedupe and compression and amount of data transfer and walking of the file system and so on. I shared a couple different scripts yesterday and some commands that are available on my GitHub page. Specifically like the Windows Defender exclusions or the documentation link to the different items inside of Enable Backup that you would want to make sure that your AV products and your security products have whitelisted so that they don't overall slow down the process during recovery. But yeah, you could cut your time in half, or even cut your performance in half, or performance down to a third of what it would have been with those kind of tools behind the scenes. Let's see. Okay, so I'm getting some feedback here on the different deployment packs, on the AV. Appreciate you guys chiming in on that one. Thank you. It's always nice to have those, even if they're not really questions, just the validation or the confirmation as we're going through here. So appreciate everybody that's chiming in here. Let's get back to our topics here. So I'm probably not going to hit virtual drive. We've got still a few minutes here, but I want to talk through a couple other topics too about building out the environment and configurations, things of that nature. Reactive recovery. This bare metal recovery could have been a reactive recovery. I've mentioned that already. We could have went in and repaired Bob's server by, just blowing away the environment and rebuilding it from scratch. But there's no guarantee that it would have worked. And it looks like it's going to take longer than the 5 minutes it really took me to start a virtual machine. So I wouldn't have done myself any favors there, other than the fact that I don't have to go back and fail him back over later. But I've got him so he's not looking over my shoulder. And that is worth something. It lowers the stress level during a recovery. I helped a partner here very recently with a ransomed environment, and we ended up shipping some drives, building some speed vaults, doing some other configuration. I've helped partners, here locally and regionally, within a 2-hour drive, with some recoveries where we've, exchanged hard drives, empty drives for full ones in parking lots, preserving a chain of custody on drives from point A to point B. While those are not typical services that we provide, typically, if you've got the available bandwidth, you can recover it as fast as I can recover it. However, if your environment isn't quite there, you haven't done testing, you don't have it set up or optimized, or the customer doesn't have hardware to go and do some of these things, or bandwidth to do some of these things, you could be in a pinch. So we can try to work with you there in those scenarios. They may not be a standard support offering. You might get told no once or twice before somebody does say yes. But if you have issues during recovery, the best thing you can do is open a support ticket. Don't do it through the website. Don't do it through chat in the product. Actually pick up the phone and dial into support and choose the critical support queue that will get you into priority critical support resources if they are currently available. If they're actually all working on active live recovery tickets and things of that nature, you might get a frontline or second line guy that's going to collect some information for you and get you in a queue to be called back by an application engineer as soon as they are free and available. But you're going to use that when you are on site, server down, technician waiting kind of scenarios. And I don't care whether it's a production environment or a test environment. If it's a test, but the customer is sitting there watching you test this recovery, and if that test recovery fails while he's watching, it's going to damage your contract and the viability of these machines. Well, that to me is business critical. It might not be mission critical, but it's business critical. Your business, not your customers. So feel free to escalate or self-escalate or prioritize these tickets when you call in. If it's your first time recovery and you're still in evaluation mode and you're not sure if you did it right, you've never done it before, and it's not truly critical to your business, go through the normal processes. Let the frontline guys work with you, let them escalate it as needed. Go through those steps. But if it is truly critical and you consider it critical to your business or the success of your business or your customers, prioritize them that way. You can always self or reprioritize through the online system after you've got a ticket created. You can always self-escalate. If you're talking to a frontline tech, he's going to do his best to try to help you out in every way possible through documentation, best practices, examples, getting your environment set the right way. If he needs to elevate that up to a second, a third, an application engineer, or even to development, he does have to go through certain checkpoints typically to get things where they need to be, capturing debug logs, getting you to respond back to various configuration settings. Did you try this? Did you try this? Have you done this? I know some of it seems basic and you probably did that before you even called into support, but they have to check some of those boxes traditionally to get things escalated. If you hit your point on that one, and you've already done all these things, you've done this, you've done that, and you do need to self-escalate, by all means, let the tech know, hey, can you please escalate this up, move it up to the next tier, move it up to critical support, what have you. If you need your account rep, your customer success manager, or somebody like me to assist you in an escalation, I can escalate for you as well. And while I'm not tech support, I do get involved in a handful of really interesting recovery scenarios, multi-terabyte exchange DAG configurations and interesting virtualization clusters and hypervisors, which we may not officially support, but that's all the customer has to restore back into. So if you think I could be of help, don't hesitate to reach out to me. Probably wouldn't make me me the first call, or if you do make me the first call and you get my voicemail, or I'm traveling or out of office, things like that, leave me the information, open your normal support ticket, escalate it, critical support. Feel free to copy me into your support ticket. Once you get it, add me into the email. I can monitor and follow it, provide some additional guidance. I don't want to step on support. If I find something that's going to be helpful for them, I'll share it with you and I'll share it with them. Or if we start something together, then I can record or help create the ticket on your behalf and pass over the knowledge of what we've done, or at least ensure that we've got a stage ticket there should I not be available for the entire recovery process. You've been hit by ransomware and you're recovering dozens of machines over a weekend. I might be able to help you triage and get started with the right attack plan. And I'll recommend you either open a ticket and add me into it, or I'll open one on your behalf and add you into it. And I can provide the guidance that we've given or that I've given to support, so that way you've got a additional direct line back into support without having to recap everything for them. So those are some of the edge cases that are available there. Let's see, recovery testing. So I want to talk about futures here as we get toward the tail end of the session today. Recovery testing. There's kind of two options for you here. If you're using that recovery console that we had here earlier, it allows you to boot the machines up and screenshot them and present them in an email or in the console available as proof of life. You can also turn on our automated recovery testing, which is a billable hosted service done by Enable. We recover within multiple data centers in multiple regions throughout the world. So we preserve data within country or continent or region from where it was originally protected. It is a fully automated process that restores every 14 days or every 30 days, depending on what recovery testing plan you choose. There is no cost difference between the two, but we do limit it to servers and Windows servers and Windows workstations under 2 terabytes in size as of today. And it does not currently work with self-hosted environments. So if you're hosting your own storage nodes, you're what we call a software-only customer, then there is no way to get recovery testing automated through that implementation. You would have to utilize your own recovery console instances, which is normally the reason you went that route anyway. In this case, we provide the resources, the environment to you. You don't have to build up your own hypervisors or deploy. We basically take the 16 steps of building out a recovery console and adding a device in and starting and doing your test down to about 6 steps to add in dozens of machines into the automated testing process, where recovery console can give you daily or multiple times per daily tests. This service is going to build the VM fully, boot it, screenshot it, power it down, and purge the VM once every 2 weeks or once a month. So it is a full data transfer each time we do the test, which is not a bad thing, but not really as quick as just a Delta. We trade off data transfer for storage. We don't want to retain all that VM information between those tests. We don't want the liability aspect of it or having your data hosted someplace else. We only restore it as proof of life, and then we purge it immediately after we take a screenshot. It is secured. Your keys are controlled separately and vaulted separately from the data and the location, and they're only acquired automatically by the system when it's doing the recovery. So they're not hands-on by an engineer or anything of that nature. This is the beginning or the infrastructure that we're going to utilize to perform our continuity focus. And that's going to lead to things like a replacement to the recovery console. So if you come into your backup.management dashboard and you look at recovery testing over here on the left, you're going to see any of your available devices that you've turned on recovery testing for. And you can see I've got success in recovery testing. I'm sorry, I've got failures on this device. I apologize. Failures on this device for my recovery testing over time. Over here, I've got completed and a completed with error on this device. Here I've got a series of what looks like completed And I personally am red-green colorblind, so me understanding the difference between these is not real easy. I actually have to look at the check boxes and the exclamation marks and things of that nature to understand what it is, more so than the actual color bars. But as I come in here, I can come over and view my screenshots to see was this particular recovery successful. Here we did a October 14th at 11 a.m. recovery test based on a September 27th backup. So that's the restore point that it used, and this is when it actually did the test. Not only did it boot and come to a screenshot, you can see my login here. Oh, something happened and your PIN isn't available. So yeah, I can't, it opens this up in an isolated environment, so I can't use my Windows Hello to log in this environment. It's not able to really log to anyway, but you see that login screen. That's interesting. I haven't seen that error before, but we capture information on this one, but we isolate it so it's not going to be able to talk to a domain or send any email or do anything of that nature. It is fully isolated and self-contained with no available outside access while it's there. Let's go down and grab another one down here. I don't have screenshots for my failed ones. Let's look at 03 here and see what it looks like. So this one took about 6 hours to do the recovery. It's a October 12th restore from an October 11th session. I'm doing testing every 2 weeks here. And you can see here, October the 12th at 8:09, that's my login. That's my proof of life. It's the equivalent of opening the refrigerator door to see the light come on, but it's not really a sniff test or a date check. So it doesn't replace getting in there and actually doing occasional manual tests or taking a test that we've done in the recovery console, or you've done in the recovery console, and actually logging into it and booting it up and doing the things that would cause it to be blocked later. Get your customer involved. Charge them for those extra access and efforts. Let them understand the fact it's going to run at 50 or 60% of its normal CPU and memory utilization because of the way you've got things provisioned. Assuming you're going to fail over possibly not just one, but dozens or a subset of machines for their environment when they have a failover, orchestrated failover versus just machine failover, those kind of things. Please also don't confuse the fact that I can spin this up at a location or in an Azure cloud or someplace with a full business continuity solution. You still have to have an infrastructure where your customers have remote access, that have laptops, that have roaming profiles, that have VPN software that you can configure and connect. Maybe a distributed AD, because if your AD is down and the production site's not available, the fact that today is in the cloud really doesn't help you. So maybe it's a distributed AD environment, or you're going to spin AD up as well as the SQL Server. And even then, if the job isn't designed that the user can work from a hotel lobby or from a hotel room or their home office or a temporary office location, then having the data in the cloud may not do anything other than prove that the business can get back once you have a new site and you have new hardware. Having data and getting access to it is not the full solution. Okay, we just provide pieces of it to you, make it available through tools that really don't cost you a lot or don't cost you anything in some cases. So imagine taking this a little bit further here. And in the scenario, instead of just having testing here, I would find different plans, and I could come in and choose my restore weekly, restore daily, test weekly, restore hourly, test daily, retain one instance, retain 5 instances. So I could switch between multiple checkpoints there. Instead of having to roll forward or roll backward, I could just utilize multiple VM checkpoints and differencing disks. Imagine that not only into seeing recovery policies here or plans here that you can utilize. Imagine having a drop-down list here of different storage locations. So you've got your Azure location, you've got your colo, you've got your customer site 1, customer site 2, customer site 3, where they have their own Hyper-V server with a recovery agent. Recovery agent right now replacing recovery console. That's at least the current name of it. It may change before we get to GA, but that recovery agent is written to be API aware, to run fully as a service, and then of course all of the web interface and management is done through the web UI, so you get single pane of glass or single panes of glass, filters and views to control your recovery environments. Since it is multi-tenant, you could allow potentially your clients to be able to log in and control their own switchover and failover. We see this replacing Recovery Console for an on-premise or a distributed type environment. We see this having a bring your own credential opportunity so that you can drop in your own Amazon or Azure credentials for you as the MSP and host for your customers. Although provisioning and configuration and securing access to the data, you want to make sure that you do isolate work groups and sets so that MSPs don't have access to other MSPs' data. You might find it more advantageous to use your customers' credentials for Amazon or Azure in those cases so that it's isolated and it's on their own dime for Amazon and Azure costs. That way you don't get between Microsoft and your customer from a billing perspective if they decide to stay there. If they're already in a hybrid AD configuration anyway, and they're already using some portion of Azure or AWS, it really does make sense then to just fail over to their instance, and maybe they'll choose to stay there versus continue to run on premise. So just different thoughts there, things we're looking at and evaluating. The Recovery Console replacement is I believe our next logical step. What we're going to be doing, and everything that we build from that will aid us and help us as we build out the rest of our continuity strategy. I've got just about 4 minutes or so before the top of the hour. I want to check just quickly if I've got another slide or two here that I need to or want to touch on. If you wanted to do your own Amazon or Azure recoveries or testing, things like that, you can restore into an Azure Nested Hyper-V environment, like a DV3 or DSV3 series. 2016, 2019 roles. I guess they've got 2020 or 2022 roles, I guess, now in Azure as well. So whatever the latest and greatest available are there. But you'll need a certain minimum amount of CPU and power, and make sure the Hyper-V role is turned on. For an AWS perspective, I don't have an AWS native restore, as well as I don't have an Azure native restore. I'm restoring into a nested Hyper-V, so it looks just like Hyper-V if it was in your environment. For AWS, you can utilize an AWS bare metal instance, but it means you're licensing or buying that entire instance, and that could be overkill for what you're doing. It really depends on the scale of your infrastructure, and it might be more cost-effective to grab a local colo and local data center and just stand up servers or lease racks and systems there to to provide this type of configuration if you need it. But in AWS, Windows Server 2016 to 2019 with a Hyper-V role would be sufficient to do some of this type of structure as well. I haven't, I've kind of left out VMware here a little bit. We can work with VMware, and I can work in those cases. I technically believe I see better performance from a Hyper-V perspective than I do in VMware. Plus, the licensing costs and structures make more sense when you're looking at it from a failover perspective, not a production perspective. Once again, my opinion on this one. You guys could be VMware shops getting great price points and discounts on that one. And if you want to go that route, obviously you could. So given that, I think I've got one final slide for you guys. If there is anything that you do need from me, any queries, questions, things I mentioned today that you want more information on, don't hesitate to reach out to me via email. My email address can be seen in the system here as I'm talking. It should be blaring my email address up and my Twitter handle. I've got a final wrap-up poll, and you've already seen this if you've been here during the week. And this is just about how valuable did you find this type of session. It was a little bit different from the scenarios you saw earlier in the week, based on putting in the context of a user and his SLAs and so on. Does that work better for you guys? Does telling a story, is it more useful? Is it more appropriate to fit it to what you might run up against? Or do you just want the raw how-tos and the whys and those kind of items through a normal typical lecture style class? So let me bring back up the recovery environment. Let me see where we are. Oh yeah, I definitely have some kind of performance problem someplace. With an 18-hour estimate and 1 megabit processing speed, something is definitely slowing me down. I'll figure out what that is. I'll get it improved. I'll turn it into a white paper or a blog article of best practice. Speaking of that, there are Amazon and Azure recovery blogs out there on how you can do inject into Amazon Azure. Where you can recover to a local Hyper-V, local VMware, create a local VMDK or VHD, and then inject it or upload it into Amazon or Azure, and then use it as a template or workload there to build out a VM. And I've taken it both ways. I've taken it round trip from Amazon Azure down local and then imported it back in. And then I've taken machines that were recovered local or built local on premise and injected them into Amazon Azure for the first time. So a couple blog articles available on enable.com/blog that will take you through those processes, as well as several other good blog articles I've talked about during the week. I think that's everything I've got, guys. I appreciate your time and attention today. Thank you for letting me talk your ear off all week. 9 hours is a lot of time to ask from anybody. I know that you guys have had other fires and things of that nature you've had to work on. Customers, you may have been unattentive at points, had to step away. These should be made available, either this edition or may replace a existing one in there. But there is, as of right now, also a series of backup boot camps and recovery boot camps in there that you can grab and watch. Content may be slightly different based on target and flow, but you're going to get the general gist of it. It's indexed. You can go right to the chapter and section you want to talk about. I think I've answered all my questions as well, so I don't see anything else that we need to do here. So I will let you guys get back to your day. Have a great weekend, and please reach out to me if I can be of any assistance in the future. Have a great one.